Assalamu alaikum everyone. This is lecture 1. So in this video we are starting our Scikit-Learn tutorial series. In this first lecture we are going to talk about something very important, that is trend test split. Now let's understand what is trend test split. When we are building a machine learning model, we use data, but we don't want to just train and test the model on the same data. That would give us fake results. The model would just memorize everything and perform well, but it will not be able to generalize to new data. So what we do, we split the data into two parts: training data, which we use to train the model; testing data, which we use to check how well the model performs on unseen data. This is called trend test split. It helps us test the model in a realistic way. Now let's see how to actually do this in code using Scikit-Learn. So open your Imputer notebook. I'll share this notebook with you in this video description. So this is the dataset. So first what you have to do, you have to import pandas library, and then you have to read the dataset, which is the very basic step in machine learning. So pd.read csv, this is the data. Basically this data, first we need to understand the problem statement. Now in machine learning, the first type is supervised learning. And within supervised learning, we have two types of ML problem: classification problem and regression problem. So in supervised learning, we have label data like input features and target column. So if the target column has classes like binary or multiple, like 0, 1, yes, no, true, false, then it is a classification problem. But if in target column we have continuous value, then it will be a regression problem. So at the moment we have classification problem. So this data set has customer details like customer age, customer salary, or you can say employee, experience, gender like male and female, department, education level, location score, and purchased, which is a target column, and it has two values, 0 and 1. Now for now what we are going to do, we have to just split this data into two parts: train and test. And in Scikit-Learn, what you have to do, you have to go to Scikit-Learn, and from Scikit-Learn.model selection you have to import trend test split. This is the function that is used to split your data or divide your data into two parts: training and testing. Now for that, first we need to grab input features and target column. So what I'm going to do, I'm going to store all the input feature into X. So my data has df, so I'll simply drop target column like this, which is purchased on axis 1. Axis 1 means that I am going to drop this column column wise. If I pass here 0, then it means that I am going to drop it row wise, but I am going to drop it column wise. Okay, so now what will happen, from this entire data, purchased column will be dropped, and remaining all the columns will be my input features, and they will be stored in X. Okay, next I am going to store target column into Y variable. So what I'll do, I'll simply go to dataset, and there I'll pass purchased. Now if I show X, you will see all the input features like age, salary, experience, gender, department, education, and location scores have been stored in X variable, and you will see my target column values will be in Y, as you can see 0 and 1. Now let's trend test split this data. So what I have to do, I have to just call this trend test split function, and I have to pass my X and Y, because all my input features values are stored in X and target column values are stored in Y. Now here I have to specify test ratio. So here you have to pass a parameter test size. It should suggest me. And here I am going to pass 0.2. What does it mean? It means that I am going to split this data into two parts, 2%, 80% and 20%. I want to store 80% data into training set and remaining 20% data into test set. So I have to create four variables: xtrain, xtest, Y-train and Y-test. This is important. Now all input features values are stored into X. So 80% data from X will be stored in X-train, and remaining 20% data from X will be stored in X-test. From target column, we will have 80% data into Y-train and remaining 20% data will be stored in Y-test. So if I just show you the shape, X-train.shape, X-test.shape, Y-train.shape and Y-test.shape, you will see the total we have. If I just show you the data set df.shape, total we have 200 customer or employees, or you can say 200 rows. So what will happen? From 200, 160, which is equal to 80, will be stored in X-train. As you can see, 160, which is equal to 80% data from input columns from X, and remaining 20 will be 40, which is stored in X-test. And the same thing goes with Y-train and Y-test, but from target column. So in this way you do trend test split. Now the question is, why we do trend test split? As we already mentioned that we are going to train model on X-train, which is 80% data from input features, and Y-train, which is 80% data from classes. So once the model is trained on this input and output values, then we will have to test that model on X-test and Y-test, so that we can check model performance before introducing that model into real world or production system. So here X is our input features, Y is the output, or you can say labels. Test size 0.2 means 20% of the data will be used for testing and 80% data will be used for training. Okay, one thing more, here you have to pass random stat. That is a parameter. Let me just copy this one. It just helps to make the result reproducible. Okay, so let me paste it. Nothing else, you have to just pass each time whenever you are dealing with any type of data set. After this, what we got, X-train, Y-train, which is for training, X-test, Y-test for testing. But one thing more, here you can see I have passed another variable or parameter, that is stratify, where I have passed Y. Other things are as it is. What does it mean? It could be a bonus step for data scientists that could be provided by Scikit-Learn. Whenever you are working with classification problem and you want to keep the same class distribution in both train and test. Now you can see, if I show you, if I show you DF and my target column is purchase and value counts, you can see this data is imbalanced. As you can see, 0 is 104 and one class is 96. So if you want to keep balance for both training and testing sets, then you can pass stratify. So I recommend that use this as well. What is encoding in machine learning or Scikit-Learn? So whenever you want to train a machine learning model on your custom data set, then there in your custom data set there will be some kind of categorical columns. Now if you want to train an ML model, then ML model will not be able to understand that categories. So you have to explicitly convert that categories into numbers. So encoding is the process of converting categorical non-numeric data into a numeric format so that the machine learning model can process it. As you can see here, we have a column by the name of color, in which we have different types of categories like red, green, blue. Now if you want to train an ML model on this column, then you have to convert all these numbers, all these categories into numbers, because ML model can only understand numbers. So we have three types of encoding technique in Scikit-Learn. The first one is label encoder. So label encoder is basically used to assign a unique integer ID to a category. As you can see, we have green, red, black, green. So after applying label encoding, it's been converted into 1, 2, 3, 1. Now wherever machine learning model see 1, it will understand that 1 means green, 2 means red, 3 means black, 1 means green. So now let me show you that how we can apply on our data set. So I am using the same previous data set, binary classification, customer or employee data set. Let me show you. Now in this data, I have already mentioned that this is a binary class classification problem. Okay, supervised learning problem, because in supervised learning problem we will have label data. Label data means you will have input features and corresponding target column. So now you have to train your model on this data. But as I mentioned that machine learning can only understand numbers. So machine learning model will work on these 3 columns and this column as well. But these 3 columns are not numeric or continuous. They are basically categories. So in gender column we have 2 categories, male and female. So we have to convert them into 0 and 1. And in department we have different categories, and in education as well. So if you want encoded data, then you have to apply 3 kinds of techniques that has been provided by Scikit-Learn. So the first one is label encoder. How to import label encoder? You have to import from Scikit-Learn, from Scikit-Learn.preprocessing, import label encoder. So if you double tap, it will suggest you label encoder. Then we have to create an object by any name like encoder. So label encoder. Then we have to apply this specifically on these 3 columns. Like first I'm going to apply on gender, then department, then education. So what I have to do, I have to call encoder encoder dot fit transform. There is a method fit transform. You have to call this and you have to pass the column, and the column name is the first one is gender. So this is gender. Now currently you can see in gender we have female and male. So let me apply and let me also store the result in gender again. So gender like this. So let me apply. If I show the data set again, now you will see in gender column we have 0 and 1. So the first 2 values were female, female and male. And you can see label encoder assign 0 to female and 1 to male. Now let's apply on department. So let me copy department, then encoder.fit transform method and pass your department column, right? Before running, let me show you just quickly unique values for department. So df dot department dot value counts. As you can see, total we have first, second, third, fourth. We have 4 categories, 4 classes. So after applying label encoder, if I copy this line of code from here and paste it right here, you will see now we have 0, 1, 2, 3. So label encoder internally assign 0 to engineering, 1 to HR, 2 marketing and 3 sales. Now let's do the same thing for education. So if I copy this line of code and paste it right here and let me call education column, so you will see in this we have again 4 categories: bachelor, masters, high school and PhD. So if I go to dataset, education, then our encoder dot fit transform and pass our data education column. So now you will see data. As you can see, now we have gender, department and education. So now we have successfully encoded all these 3 columns. Now we are ready with our input features to be used for training. Ordinal encoder is a class that you will be using anytime whenever you are dealing with ordinal data. But before that, let me revise that what is encoding in machine learning. So basically in machine learning, your main objective is to train an ML model. And for that ML model, you need a data set. Now in data set, you will have input features and corresponding target column. But in input feature, there will be some kind of categorical data. Like in case of gender, we have male and female. So any machine learning model will not be able to understand male and female. You have to encode them into 0 and 1. That is known as encoding. So Scikit-Learn provides you 3 types of encoding technique. Now the question is when to use which one. So in previous video we already seen label encoder, but we implemented on all 3 columns. But basically label encoder is used for binary categories like male and female, or target column like yes, no, 0, 1. Whenever you have 2 categories you can use label encoder. But if you have a categorical column like education, and in that education column you will let's say ordinal data. Ordinal data is that data where you have higher values, like one class or one categorical data will be higher than other one. As you can see, high school is less than graduate, graduate is less than postgrad. So if you are dealing with ordinal data where order matters, then you will have to use ordinal encoder. So we are going to use the same data, binary class classification problem. Let me quickly give you an overview. As you can see in this data we have 3 columns: gender, which is a categorical, department, and education. So now if you want to convert gender, you can use label encoder that we already seen in previous video. But if you want to convert education, because in education we have ordinal data, then you have to use ordinal encoder. You can also use ordinal encoder for department, but in department we have nominal data. There is a difference between ordinal and nominal data. So first let me quickly drop null value. Now this is the code. From scikit-learn.preprocessing you have to import ordinal encoder. So previously we have imported from preprocessing label encoder. So all the 3 classes you have to import from preprocessing. So here once you import the class, as we imported ordinal encoder, then you have to create an object. So we have created an object by the name of ordinal encoder, and this is the class ordinal encoder. Now we have to apply this ordinal encoder on the categorical column that we want to convert. So as you can see here, in this education column we have values like bachelor's, high school, PhD. So this is clearly a sign of ordinal data. Now on this column I am free to use ordinal encoder. So ordinal encoder dot fit transform, pass your data. But to pass your data you have to specifically mention 2 dimension, because our data is in 2 dimension and this education will comes in 2 dimension. You cannot pass like this, like education. If you run it, you will get an error. Let me show you the error. As you can see, we are getting an error related to dimension, expected 2 dimension container, but got this pandas series is 1D. So what you have to do, you have to just change it to 2 dimension, right? Like this. Now as you can see, if I run it, let me also remove this thing. If I run it, you will see now education is converted into numbers. So now these values are in float. So internally what ordinal encoder do, it's convert your ordinal data into numbers, but the final result will be a float value. So what you have to do, you have to just type here, you have to change the type as an int. So now if you run, you will see 0, 1. So just let me quickly show you. If I go to df.education and value counts, as you can see, basically I have to rerun it again so that we can understand how it looks like. As you can see, we have masters, bachelor's, high school, PhD, right? So now you will have 0, 1, 2, 3, total 4 values. Okay, so in that way ordinal encoder is used to convert your ordinal categorical data into numbers. Now let's apply the same ordinal encoder on department and let's see what happens. So what I have to do, just let me call department column and let me call ordinal encoder and fit transform method, and there we have to pass our department column, and let's explicitly change the type. to int. So if I show the df, now you can see in department you also have numbers. So now we successfully converted department values. But one thing more, here you can see education, here education values were converted, but here it's again ordinal data or categorical data. Why this happens? It's only because I forgot to rerun this cell. As you can see, if I rerun my dataset cell, this cells, and let me rerun. Now you have converted. Now let's run this cell. So finally we successfully converted all the categorical data either from education or department into numbers. Now we can go to train a machine learning model on this data, but you have to also convert this gender. So in this video we are going to discuss one hot encoder in Scikit-Learn. But before that, as in previous two videos, we have already discussed what is encoding. So let me revise. Encoding in machine learning is the process of converting categorical data into numerical format so that algorithm can process it. So if you want to train an ML model on some data, then there might be in that data set you will have some categorical data. So before feeding to ML model, you need to convert them into numbers, because ML model can only understand numbers instead of categories. So in previous two videos we discussed two different classes like label encoder and ordinal encoder in Scikit-Learn. So the third and last class for encoding categorical data into number is one hot encoder. So one hot encoder in Scikit-Learn is used to convert categorical data into binary 0-1 matrix. This is a little bit different from previous two classes. So one column for each category. So it is used for nominal data, as label encoder is used for categorical column, and ordinal encoder is used for ordinal data where data order matters. But one hot encoder is used for nominal data, the data that has only names where no order matters. Like in color you can see red, green, blue. These are just names. There is no issue with the order. So here you can see we have a column by the name of size in which we have three unique categories: small, medium and large. Now if you want to apply one hot encoder class from Scikit-Learn on this size column, so what it will do, it will generate three other columns: size small for the first unique category, size medium for second, and size large for large category. So what will happen, for each category it will have a list of 0 and 1, a matrix of binary values. So if in size first row we have a category by the name of small, so here we will have 1 0 0. Now below the new column which is by the name of size small, there will be a 1 which represent on, and the two remaining categories like size medium, size large will be off, meaning 0. So 1 0 0 means if machine learning model get 1 0 0, it will understand that 1 0 0 means small category. And for medium, what it will do, size small column will be off, meaning 0, size medium will be on, and size large will be 0. So whenever machine learning model see 0 1 0, it will understand that 0 1 0 means medium category, and for large 0 0 means small and medium will be off and large will be on. So now here you can see smalls, here we again 1 0 0, because small category has a list with binary values 1 0 0. So wherever in upcoming rows the ML model sees small, it will get 1 0 0, right? So basically one hot encoder create new columns based on the size of the categories that size column have. So now let's implement in Scikit-Learn. I am using the same binary classification data. So there we have gender, department and education columns which are categories. So education has two values, male and female, so on that column you can use label encoder. Gender, and education has nominal data where one category matters. Okay, so on that data you can use ordinal encoder. Now in department we have only names, so for that you can use ordinal encoder. So let me quickly remove drop values and let me quickly show you unique values in department. So in department we have cell, HR, engineering and marketing. So we have 4 unique values. So once we apply one hot encoder, it will generate 4 new columns. But before applying in the correct way, let me apply in the wrong way as traditional. So from Scikit-Learn dot preprocessing, you have to import one hot encoder. Same like from preprocessing we have imported previously label encoder and ordinal encoder. Now first we have to create an object of one hot encoder. So this is one hot encoder, and this one hot encoder you have to pass couple of parameters that I'll explain a bit later, like drop I'll pass first and sparse output will be false. What does it mean? I'll show a bit later, but let me quickly apply a department variable so that we can see what happens. So call encoder and then call fit transform method and pass your department column. So if I show data set, you will see, let me quickly also convert them into integer. So now you can see we have in department column total we have 4 unique categories. Okay, but after applying one hot encoder on department column, what we get only 2 values, 0 and 1. So this is totally wrong. You will not get the correct conversion from categorical to number encoders. So here we need a little bit custom code whenever you are dealing with one hot encoder. So what I have to do, I have to comment this code like this, and just let me copy this 2 things from here, Control C, and then let me rerun. So I have imported one hot encoder in the same way and then created an object in the same way. So what I have to do, I have to first extract the column that I want to convert, that is department, or let me directly give it a name. So department. Now I have this column department. Okay, so now I can apply this encoder. So let me create another variable by the name of encoded column. Then I'll have to call this encoder and then fit transform method, and then I have to pass data, but this time I have to just pass my column because I'm not going to pass all the data. So df call, now you will see something else. So encoded call, now you will see a numpy array, and for each category you will get a list. So total we have 4 unique categories, and for each category we have a list with 0 and 1, but there must be a 4. Why 3? It's because the first, we don't need the first one. It will automatically considered by a machine learning model. That's why we pass first will be drop. So if I remove this thing and let me rerun, you will see 4, because actually we have 4 categories. So logically there must be 4 values within a single list. Now for each category we have a list, and that list represents that category in the same way that I have explained in the initial part of this video. Now let me pause as okay. Now why we are going to drop the first column? This is the first list, this one. Why we are going to drop? So if machine learning see these 3 things, it will automatically consider, the machine learning model will understand that what the first category contain. So just for sparsity we are going to drop the first one like this. So now we have 3. Now I have to create a proper data set so that we can see it now. So let me create encoded df, and then I can call pandas data frame method, and I can pass my encoded column because I'm interested to create a data frame of this array. So encoded call, and I also want the column name, so I can pass here columns. And how to get the column names? We have already a trained encoder on that column categories, so you can extract from there. So encoder there is a function by the name of get feature names out. And what was the feature? I mean the column, it was call. So if I show the encoded df, you will see this data frame. As you can see, now we have this data frame. Why? It's in float, so you can convert them again into int. As you can see, now we have a proper list. Now I have to concatenate this data with my original data. So what I can do, I can call final df and then pandas. There is a function by the name of concat. You can pass your list, original df and my encoded df. I want to concatenate them column wise, so here you can pass access will be 1, but still you will get some null values. If I show the final df, we get the result. We get, as you can see, now we have new column: department HR, department marketing, department sales. So one hot encoder is working, but the only issue is, you can see we generated a lot of nan values. It's just because of mismatching between the index, between the actual data index and encoding data index. So what I can do, I can either directly drop, like if I just say final df dot drop any in plus will be true, and if I show final df, no, we don't have any null value. But if you don't want this thing, let me cut this part. You can explicitly do one more thing. Before concatenating, you have to reset the index, like encoded df, let me call index will be equal to original df, so df dot index. Now let me rerun everything again so that we can see. Let me run this, let me zoom out a bit, and let me run this, and let me run this, and now let me run this, and finally this, and this is my final data. As you can see, now we have successfully converted. Now you can drop department column, you don't need it because we have already encoded its category. Data scaling techniques. Now in machine learning you might have heard about data scaling. So before explaining, let me give you an example. Suppose you have this data set and you want to train a machine learning regression model, okay, not classification but regression model. So in this data set for now, let's say that we have only these two columns, age and salary. Now in age we have three values like 20, 40 and 60, and in salary we have 30,000, 60,000 and 90,000. So if you train a model on these two columns, the model will, within salary, the model will mainly focus on 90,000 because it is a higher value. It will mostly skip lower value, but mostly will be dominant or mostly will be biased for higher value. Okay, in the same case in age. So if you want to train a balanced model, and if you want to give the model equal importance to each value, then you have to scale this value or bring this value into a range of 0 and 1 so that the model give equal importance to each value. Okay, for that machine learning or scikit-learn provide data scaling with two types of technique, normalization and standardization. So in this video we will focus on normalization, but before normalization let me quickly explain data scaling. So data scaling transforms features are your input features to a similar scale so that no single feature dominates learning. It improves model performance, especially in algorithms like KNN, SVM or gradient descent based models. Without scaling, models may converge slowly or produce inaccurate result. So now let's understand normalization. So normalization in scikit-learn or machine learning bring feature values between the range of 0 and 1 using this formula. So let's say we have this two column, age and salary, and before running machine learning model we want to scale both these features so that our model perform well and give equal importance to each value. So the formula is x minus x minimum value divided by x maximum value minus x minimum value. Now understand this. For now let's focus on age column. We are going to scale age column using normalization. So age has three values, 20, 40 and 16. Okay. Now age represent x. So we have to figure out the minimum value. So in this entire column the minimum value is 20 and the maximum value is 16. So here we are going to implement this formula for the first value. So x, which is 20, minus x minimum, which is the minimum value in the entire column, divided by x maximum value, which is 60, minus x minimum value, which is again 20. So x minus x minimum, which is 20, the actual value minus the minimum value, divided by the maximum value, which is 60 minus minimum value. So if you calculate this, you will get 0 value. So now for age, the first value, which is 20, after scaling you will get 0. Let's do the same for 40. So 40, which is the actual value minus the minimum value, which is 20, divided by maximum value, which is 60, minus minimum value, which is 20, will be equal to 0.5. And the same formula for 60. Then finally you will get this result: 0 for 20, 0.5 for the second value, and 1 for the third value. Now you can see in this column the values are being scaled in the range between 0 and 1. So if you apply the same for salary column, so minimum 30,000, maximum 90,000. So let's do the formula for the first value. So actual value, which is 30,000, minus minimum value, which is 30,000, divided by maximum value, which is 90,000, minus minimum value. So you will get 0. And if you calculate for the remaining two value, you will get this column. So again salary is being scaled between 0 and 1. So now you have seen, so we can implement the class that is used for normalization. So Scikit-Learn provide mean max scalar class for this normalization technique. So let's do that. So the first thing, let's load data set. Now for this implementation, I am going to use another data set, which is a regression problem. So let me quickly import pandas as PD. Then let's load the data set, which is a car price prediction. So there is a column by the name of name. So I don't want that column, so I can explicitly drop that column, which is name, and in plus will be true. So if I show the data set, let me rerun. So this is the data set, and in this data set we have these features like year, selling price, kilometer driven, fuel, seller type, transmission, and owner. So now the target column is selling price. So again it is a supervised learning problem because we have a label data. Label data is a data which has input features with corresponding target column. So within supervised learning we have further two types, regression and classification. So if you want to know which one we are dealing with, so you have to focus on target column. So in target column, if you are getting continuous value, then it is a regression problem. If you are dealing with classes, then it will be a classification problem. So at the moment we have this continuous value like price prediction for car based on year, how many kilometers that car has been driven, fuel type, seller type, transmission, and owner. Then we have to predict the price. Okay, so this is the regression problem. But in this column, the first thing we have to do encoding. So in this entire playlist we have already seen you can use three types of encoding technique, but we will use one hot encoder or ordinal encoder for all these three. The second thing we have to do, which is the part of this video, that is this two column, kilometer driven, sorry, this one, kilometer driven, selling price, and year. These are numerical values, so we have to bring into a range between 0 and 1 so that the model give equal importance. One thing more, you cannot apply any technique, either normalization or standardization. I mean, for data scaling, basically you use two techniques, normalization and standardization. So you cannot use both of them for categorical data, okay, but you can only use for numerical data. Perfect. Now the first thing, let me quickly check missing value. So I can see I don't have any missing value for this data set. Now let me quickly copy this 4 column, because the first thing I have to do, let me encode this data set. So columns, calls, and let me create a list of this. So I can do like this. So now these are the columns I want to encode. So let me import from Scikit-Learn dot preprocessing import Ordinal encoder. So for now I'm just using Ordinal encoder for all the columns, but it still depends. If there is a binary value, then you can use label encoder, and if there is ordinal data, then you can use ordinal encoder. But if there are just names and there are no values that matters, meaning the categories are not matter, then you can use one hot encoder, as we have already seen in this playlist in the previous few videos. But let's see. So let me create an object with the name of ordinal encoder. Then let me apply on all these columns encoder. So dot fit transform and pass all columns. Okay, and let me print the data set. So let me quickly convert its type to int. So now you can see fuel, seller type, transmission, and owner categorical values have been converted into numbers using ordinal encoder. Perfect. Now the second thing, we have to work on these 3 columns using scaling technique. So let me add a cell here. What you have to do, from Scikit-Learn dot preprocessing, you have to import mean max scaler. Now if you want, basically as I mentioned that you have 2 types, normalization and standardization. There is a little difference between these 2 techniques. In the upcoming video we are going to discuss about this, but since we are discussing in this video normalization, so for normalization, Scikit-Learn provide this class mean max scaler. So what you have to do, you have to create an object like scalar will be equal to mean max scaler. Then I'm interested basically in this 3 columns, so let me explicitly Control C and let me create numerical calls list. Oops, like this. So let me quickly set and like this. So now you can see we have this 3 column: year, selling price, kilometer driven. And now let's apply scalar. So df, I want to convert or scale these numerical columns, then call scalar, not encoder but scalar dot fit transform, and then pass your column, which are numerical column. So now if I run or show the data set, you will see something else. So in year we have this numeric data like 2007, 2012, and in selling price we have 60,000, 1,35,000, this, and also for kilometer driven. But now after scaling, you can clearly see now all these values are between the range of 0 and 1. So if you train a machine learning model on this data, then the model will give equal importance. Now there is no guarantee that this system will work for any type of data set. So in some cases you will get better result. After that, let's do trend test split. So for trend test split, you have to import from Scikit-Learn dot model selection import trend test split, and then we have to extract all input columns. So df dot drop our target column, which is selling price. So let's Control C and Control V on axis 1. It's mean column wise, and target column will be stored in Y. Now let's create for set xtrend, xtest, ytrend and ytest, then call run test split function. We have already seen about run test split, so you have to pass input feature target column with the test size, which is 0.20, meaning 80% data will be used for training and remaining 20% data will be using for evaluation or testing purposes, and random state always use 42. So let me run it. What I can do, let's train a linear regression model before applying this technique. So let me rerun this entire thing, load data set, and like this, encoding. Now we have this data. Okay, as you can see, it is not scaled. So for now, let's skip this cell as it is, and let me also run this. So I am going to train a regression model. Now as a beginner, if you don't know what is a regression or linear regression model and when to use linear regression model, we will see in upcoming videos. But for now, let me train a linear regression model, or you can say regression model without scale data. So currently we have this data. So for linear regression from Scikit-Learn .linear model, you have to import linear regression model, linear regression, and let me also import from Scikit-Learn .matrices, import AutoScore. Now in previous classification problem, we have seen that whenever you want to evaluate a classification model, then you have to use classification report, accuracy score, confusion matrix. But whenever you are dealing with regression model, then you have to use AutoScore, and for error evaluation you can use root means. We will see that a bit later, I mean in upcoming videos, but for now let me use just AutoScore to see the model performance. Let me create an object for linear regression, and then let me train model lg.fit my xtrain, xtest, and then create ypred will be equal to lg.predict on xtest. Perfect. This should be ytrend, by the way. And once you do that, then you can calculate AutoScore by passing the data that has not been seen by the model, which is ytest, and the data that has been predicted by the model, which is ypred, and run it. So we are getting 39 accuracy for this data using linear regression. So now if I run this cell, I mean if I normalize the data set, now we have this. So you have to rerun this run test split cell as well. Now let me rerun again. Let me quickly give you a revision in the sense of the question that scaling doesn't mean that it will work each time. Sometime it will work, but sometime it will not work. As you can see here, we didn't get a little bit improvement might have been done, but still you can see the performance is as it is. Let me try one more model, a random forest regressor, but I have to rerun all these cells so that I can check it without scaling. So this is encoding. I am not going to run this cell, but let me run this and let me pass this code. So from Ensemble I have imported random forest regressor. Now a lot of model provide both for classification and regression. Like in case of random forest, if you are dealing with classification problem, then you can import random forest classifier. But if you are dealing with regression, then you can import random forest regressor. We will see that categories in future, but you can see in the same way we have implemented this regressor. So now let me run it. We are getting 50% accuracy, but if I run scaling cell and rerun this, and this. So you can see again we are still getting 50. So the main objective and overall idea of this video was that if you train a model after doing some pre-processing and you want further to improve the result, then you can use scaling, training and testing for a machine learning model. So if you are a beginner, then this could be a helping video for you, because there are two ways to train a machine learning model. I'm talking about implementation wise. Once you upload your data set and do some kind of pre-processing and train test later, then you have to train a machine learning model for prediction. So you can use two ways. You can train individual model. But if you want to train multiple models, because machine learning provide multiple models for any problem like regression or classification, then for time saving and reducing your code, you can use multiple models or a group of models at once. So let's start. This is the data set. Let me reload it. You can see we have the same data set. This is a supervised learning problem, because supervised learning problem needs a label data. Label data means you will have input features with corresponding target column. Now in supervised learning problem, we have further two problems, regression and classification. So if you want to know is this problem a regression or classification, then you have to focus on target column. If in target column there are classes or categories like 0, 1, yes, no, true, false, then it will be a classification problem. But if in target column there are continuous values like in points or fractional values, then it will be a regression problem. So this is a classification problem. So what we have to do first, we have to do some pre-processing. So in our case, we have to just encode these three columns and do some train test splitting. So first let me quickly remove missing values. Then I have to implement encoding. So from Scikit-Learn dot preprocessing like this, import. So for video purpose, I'm going to use only Ordinal encoder. Okay, you can use the three encoder that we have discussed in previous three videos, like label encoder, Ordinal encoder, and one-hot encoder accordingly. But for education purpose, I'm just using Ordinal encoder. So the first column is gender. So what I have to do, I have to just call, first I have to create an object of one-hot encoder. So you can create object like this. Then we have to apply this encoder on the column that we want to convert. So it should be encoder.fit transform method, and now we have to pass our gender column. In gender we have two values, female and male. So it will be converted into two numbers, 0 and 1, right? So let me also do the same thing for remaining two columns. Let me control C, V, control V. So the second column is education, and let me also replace education right here like this, and department. So let me change the name, department. Let me control C and let me paste it right here. So now we are going to run the cell. So now you can see, okay, let me do one more thing. Let me also explicitly change the type to int. So S type int, right? And let me fix this as well. So let me run it. Now you can see in gender we have two values, male and female. So now that male and female has been converted into 0 and 1. And accordingly in department and education, we have converted all the categories into numbers. Now machine learning model will be able to understand these values. So we are almost ready. Now the last thing we have to do some train test splits. For this, what you have to do, you have to import from Scikit-Learn dot model selection, import train test split. Now we have to create 4 set. Xtrain, as we already discussed in this playlist first video, and xtest, ytrain, and ytest. And then we have to call this train test split method, and we have to pass all our input features x and target column y with case size parameter will be 0.2, because I want to store 80% data for training purpose and remaining 20% data for test purpose. And let me also pass random state. Now what we have to do, we have to extract input features. So how you can extract, there are a lot of ways, but you can directly implement this way: df dot drop target column, which is purchased, on axis 1. Axis 1 means that I am going to drop this purchased column wise. If you pass 0, then it will drop row wise, which is not good. So if you pass axis 1, it will drop this column wise. Why we are going to drop this? Because we only want to remain with this input feature, so that we can store all the input features in X, and target column will be stored in Y. Okay, so let me run it. Now what will happen, from input features all 80% data will be stored in X trend, and from Y column or Y variable all 80% data from target column will be stored in Y trend, and the remaining 20% data from input feature X will be stored in X test, and from Y in Y test. Now let's train an individual model. So as a beginner, once you jump into machine learning and data science, then you might have heard the first algorithm that you will be dealing with for classification problem is logistic regression. So all linearity algorithms, like for a regression we use linear regression, and for classification we use logistic regression. You have to import from Scikit-Learn linear model. Linear model is a class in Scikit-Learn that provide all linearity model, either for classification or regression. So from linear model import logistic regression. As you can see, we have imported logistic regression. Now we have to create an object for logistic regression. So logistic regression, now logistic regression needs couple of parameters if you want to improve model result, but we will focus on that part later. But for now, let's see how we can train. So after creating the object, we have to train our model, training model. So what you have to do, you have to just call fit method and pass your 80% data from input column, which is X trend, and corresponding target column 80% data, which is Y trend. And once the model trained, we have to test. So for testing purpose, what you have to call predict method, and you have to pass only input features 20% data. Now you have to store for this X test input feature data predicted classes. Now logistic regression will predict some classes like 0 or 1 from the purchased column. So we have to store here by the name of variable like yPred, or you can give it any name. So let me just run it, then I'll show. Now the model is trained and test. So if I show you model prediction, you will see a list of 0 and 1. This 0 and 1 are nothing but model prediction or classification from purchased column for input features. If I show shape, you can see model predicted 34 classes, either 0 or 1. And if I show test, X test shape, you will see 34. So for 34 records or for 34 rows, model predicted 34 classes. Just let me show you the first row. So for this first row, the model predicted, if I check yPred, the first class, which is 1. So here 1 represent purchased. It's mean that the customer in the first row purchased basically it's employees data, customer data. So if a customer that has 56H, sorry, apologize for that, let me give it a cell here, X test ilog method. Let me rerun. Let me also print yPred. So for first customer, so there is a customer with age almost 50, salary this, experience level this, that is male, and department, education, and location score. So for this customer, the model predicted purchased more than one model at the same time. So this is the first model. Let me import four new models. So from Scikit-Learn, there is a model decision tree. You might have heard about it. So you have to import from tree. Now you don't need to remember all those things if you are a beginner, because we will see all these things in upcoming videos. So there is a class tree, and from that you have to import a decision tree model. So import decision tree classifier. If you are dealing with regression problem, then you have to import decision tree regressor. But since we are dealing with classification, so we have to use decision tree classifier. And there is another model from Scikit-Learn.ensemble. So there you will get more models in machine learning. There is a model by the name of random forest. So again, it's used for regression and classification. So I'm going to use for classification. And there is more models. So let me quickly import them. So what happened? We imported logistic regression from linear model, decision tree classifier from tree, and random forest classifier and gradient boosting classifier. These are algorithms that are very efficient in classification from ensemble, and support vector classifier for from support vector machine, and also accuracy score from matrices. Now if I show you, just let me import Scikit-Learn matrices, import accuracy score. Now if you want to evaluate your model, then you will get all the evaluation matrices like accuracy score, confusion matrix, classification report from matrices class. Okay, so let me also print here accuracy. Now in accuracy I have to pass two things: those classes, those data for testing, as we have y-test, that has not been seen by the model, and those data that is predicted by the model, so that is y-pred. Okay, so if you see 0.5, it's mean that logistic regression giving you 50% accuracy for this data. Since it's not a good result, because we are dealing with dummy data set and it has only 200 rows, but whenever you will dealing with real world problems, you will get 3,000 or 4,000 or maybe in millions of data set. So on that data, model will perform in a more better way. And we also did not done some pre-processing like feature engineering. So yeah, this is good. Now what I'm going to do right here, as I mentioned that we are going to train groups of models at once. So what I have to do, I have to create a dictionary, and in this dictionary I am going to pass, the first thing will be named like logistic regression, and the second thing will be a value, which is actually my model. Okay, so let me quickly create a dictionary for all the models. Now we have this dictionary with model name, which is a key, and model. So now I have to run a loop for name and model in models dictionary, and there is a function by the name of items. So if I print name and model, you will see we are printing the name logistic regression and the model as it is. But what I'm going to do, I have to train the model. So once I get the model, I have to just call filter method and pass my xtrain and ytrain. So we are doing the same thing as we done for individual model, but this time we are going to do everything at one place so that we can reduce our coding. And then I have to store results in preds variable. So model.predict on xtest, and then let me print model name. So I already have name, and then let me print accuracy for that model. So the data that has not been seen by the model, which is y-test, and the data that is predicted by the model, which is y-preds. like this, and let me also add some new line like this. So if I run it, you can see logistic regression has given you 50% accuracy, decision tree 58, so you can see decision tree has improved, and random forest 44, gradient boosting again 50, and SVM 50. So how we can fine tune, or how we can use hyperparameter tuning for any machine learning model. But before that, we need to understand what is parameter and which scikit-learn class is used for hyperparameter tuning. So there is a class by the name of grid search CV that we will see a bit later. So parameter tuning is basically some values for any ML classifier or regressor or any ML model that is used to control that model, that how it can learn and how it can improve its performance on the data set that we are using. Okay, so in scikit-learn, let's say for example logistic regression, it has some parameter like C, penalty, and solver that control how a model learns. So choosing the right values can significantly improve accuracy, precision, and generalization for the model. So we are going to use the same data set, binary classification problem, and let me run it. After that, we have removed null values as previously we already seen. Then we have encoded all the categorical columns. Let me rerun. Categorical column into numbers like gender, department, and education. After that, we have done trend test split. All these tutorials we have already seen in this playlist. So if you have not watched that videos, then I recommend you to watch that videos. Now let's train our first logistic regression model for this data. So in previous video we have seen that how we can train an individual model for your data set, or how you can group a lot of model to save your time and reduce your code. But we have trained with default parameters, like logistic regression with default parameters. But let's see that how we can fine tune the parameters, and how we can use best parameter. So let me quickly import from sklearn.model selection. You have to import grid search CV. Now this is the class or function that is used to help you how you can use any ML algorithm or model parameters. Now after that, let's import from sklearn.linear model. We need to import logistic regression model that is used for classification problem. Okay, and we also need to import from sklearn.matrices. For now, just to know how the model perform its accuracy class. Otherwise, it's provide confusion matrix classification report with precision recall that we will see in the next video. So let's create an object of logistic regression. So LG will be equal to logistic regression. Now here you can pass the parameter, but what we have to do, we have to define a param grid or grid param. So let me create a dictionary with all the three values like C, and so I have defined parameter grid dictionary with three parameters. Now these three parameters are specifically used for a regression problem. If you are dealing with decision tree, then you will use other parameters that we will see a bit later. Now let's pass our logistic regression and these parameters to grid search CV. So how you have to do, you have to just define an object. So let me here define a variable by the name of grid, then let me call grid search CV. Now here you have to pass the model, which is logistic regression, the dictionary that you have defined, the list of parameters, which is param grid, and one other parameter which is known as CV. So here I'm going to use 5. Now this is a split, 5-fold cross split for my validation using grid search CV. So let's understand this thing a bit later, but let me quickly train logistic regression with grid search CV. So again, the same way, you have to do the same way, like call the fit method and pass your xtrain and ytrain, and then store its prediction into ypred variable. So grid dot predict on xtest. And now finally check the accuracy of the model. And you can also print best param. So best param, you can call greed, and within greed you can call a function which is basically best param. Okay, so you can see which are the best params. Now here you can see for C we have used 0.1, 1 and 10. These are some random value you have to pass, but these values are based on research and scikit-learn documentation. So what is C? We need to understand why we use C parameter for logistic regression. It is basically a regularization technique that shows regularization strength. So finally, if you select any value from this three value, if the value is smaller, it's mean regularization will be stronger, and the model it will prevent the model to overfit. And there is another parameter which is known as solver. It uses two values, liblinear and saga. If you are dealing with small data, then liblinear is good, but if you are dealing with larger data, then saga will be the good choice. And penalty types of regularization, L1 and L2, that is used with lasso and ridge. So these are some parameters that you will be using with logistic regression. And now let's also print. We have imported grid CV, logistic regression and accuracy score. Then we have defined the model, and this is the dictionary for our parameters. Then what we have done, we have passed logistic regression and parameter list or dictionary for grid search CV. Then we have trained, then we have tested, and we have turned the result. Now let's run the cell and let's see what happens. As you can see, best parameters for C is 0.1. Penalty, we can go with L1, and solver is saga. Accuracy is 0.5. Now since we are dealing with a dummy data and it's a small version, like we have only 200 rows, so still you will not see an improved version of the model. But if you are dealing with real data set and it's large, like 3000 or maybe 5000, then you will get better result. But still, this is the way you'll have to use for model hyperparameter tuning. Now let's understand what is grid search CV and how it works. So grid search CV is a function in Scikit-Learn used to automatically find the best hyperparameter for your machine learning model. Since, as you can see, logistic regression use three parameters, C, solver and penalty, but each parameter use some values. Now these values are based on research or could be random, but which is the best one for this current data set, we don't know. So if you want to dynamically select the best parameter, then grid search CV is the best class from Scikit-Learn. Okay, how it works, it basically tries all the combination of the hyperparameters you provide in a grid, like C, kernel, max depth, or in our case C, solver and penalty. Here you can see we have passed for grid search CV. Just let me quickly show you. CV will be 5. I want 5 cross validation for my data. But let's understand how grid search CV works. So it's basically tries to use all the combination of the hyperparameter that you have set for your model, as in our case for logistic regression, and it uses cross validation to evaluate each combination of the parameters, and finally it selects the combination that gives the best performance, I mean highest accuracy. So we have two set, training data and testing data, and you can see we have passed here CV5 in a grid search CV. So CV5 means 5-fold cross validation. The training data set will be split into 5 equal parts, which is known as folds, and the model is trained on 4 folds and tested on 1 remaining fold. And this process is repeated 5 times, and each time using different fold as a validation set. The result are averaged to evaluate each hyperparameter combination, and finally it will give you the best parameter. Okay, and you can see the plots. Now let's see how we can use parameter tuning for decision tree. Now decision tree is an algorithm that has a structure of tree, and in tree we have a parent node, branches with some nodes, So if you have heard, if you have some kind of knowledge about decision tree, then it has some parameters like criterion, max depth, minimum sample split, and minimum sample leaf. So criterion is a function that is used to measure the quality of a split, and it's used two kind of values like Gini and entropy. Max depth, how many nodes you want for your tree. Minimum sample splits, minimum samples required to split an internal node into further nodes, and minimum samples required to be a leaf node for minimum samples leaf. So again, we have done the same way, same implementation. We have imported decision tree from tree, grid, search CV from model selection and accuracy score. Then we have defined decision tree. Now decision tree use a parameter you will be using each time, that is random state. But here you can see this time our param grade is a little bit different, because this time we have passed only those parameters that are used for decision tree. Criterion with two values like Gini and entropy, max depth you can pass from smaller until 10 or 15. This could be a random value or research base. Minimum sample, and also pass one none value. Okay, minimum sample split with some random values or research base, and again for leaf. After that, we have done the same way. We have passed our decision tree model with parameter grid to grid search CV. Then we have train, we have tested, and we have printed. So once you run the code, you will get that for random forest, the best criterion parameter could be Gini for this data set. And if you are dealing with some other data set, it could be changed dynamically, and max depth could be 5, for leaf could be 2, and for split could be 2. So as you can see internally, or you can say dynamically, we are getting the best parameter just because of grid search CV, and the model performance is 52. Now let's try for random forest. Now random forest is basically an algorithm that is used internally, or combination of other trees. So it is an advanced version of decision tree basically. So it will use the same parameter like max depth, mean sample split, mean samples leaf, and criterion, but one other parameter that is known as n estimators. So once you define random forest, how many trees you want to be added into the forest, so this number estimator will decide that. So again, everything are same apart from this parameter grid. Number of estimator I want 50. Let's go with you can start with 10 to 40 or 100, but the value I have already used, as you can see, 50, 100 and 200 are research based. So if you are dealing with bigger data, then it's a good choice. Again, the other things are same. Then you can see for random forest, criterion is entropy, max depth is none because we are dealing with a very small data set, leaf is 1, split is 5, number of estimator is 10. So 10 decision tree would be a best choice for this data set to be used for random forest. And you can also see for support vector machine. Now support vector machine use 3 parameters like C, as we have already seen in logistic regression, kernel. Now if you have heard or some knowledge about support vector classifier, support vector classifier or support vector machine has 2 types like linear and non-linear. But Scikit-Learn has added more like RPA, poly and sigmoid. And one other parameter like gamma that defines how far the influence of a single training example reaches, either used in RPA, poly, etc. So again, we have done the same implementation. The only thing we have changed is parameter grid, C with its research value, kernel, linear, RBF, or you can pass the other one as well. And gamma could be scale and auto. So once you run, since this will take a bit time, so you can try and you will see the best parameter with model accuracy. So in this video we will see model evaluation. So there are mainly 2 matrices for classification model evaluation. So the first one is confusion matrix and the second one is classification report. So model evaluation is crucial to assess how well a machine learning model generalizes to unseen data. So once you train a machine learning model, then you have to evaluate that model so that you can assess that model performance before introducing it to the real world or integration with some app or website. Okay, so the first matrix that you will be using for model performance is confusion matrix. So a confusion matrix is basically a matrix 2 by 2, it could be 3 by 3, depends on the classes that you are classifying. So in binary case, you will mostly get 2 by 2 matrix. So a confusion matrix is a 2 by 2 table that is used to evaluate the performance of a binary or multi-classification model by comparing actual versus predicted classes. Now for now, just consider that you have this table and you have trained a classification model on your data set like 0 and 1. So here on left side you have two classes, 0 and 1. Now this 0 and 1 are your actual classes that are present in test set, and here this 0 and 1 are the predicted classes, I mean the classes that are predicted by the model. Now we want to compare actual class 0 with predicted class 0 and actual class 0 with the predicted class 1, and the same thing for actual class 1 with 0 comparison and actual class 1 with predicted 1 comparison. So basically we are just going to compare actual classes with predicted so that we can see how many mistakes model has done for either for 0 or 1, or how many correction or correct classification done by the model either for 0 class or 1 class. So now these two are actual classes, which is 0 and 1. Now here you can see in this cell 23, this 23 is basically the numbers or classes that are predicted by the model. So for actual class 0, model predicted 23 classes, 23 0. It's mean that for 0 actual class the model predicted 0 23 times, and that is a good sign. The more number you have in this cell, the more accurate your model will be. And for actual class 0, the model predicted 1 5 times. So it means for actual class 0, the model made 5 mistakes. Similarly, for actual class 1, the model predicted 0 3 times. So it means that for actual class 1, model misclassified 0 3 times. So the model made 3 mistakes. And for actual class 1, the model predicted 1 30 times. It's mean again here model correctly classified. So whenever you get a matrix for confusion matrix, then you have to focus on diagonal part, this dark blue color. The more value you have in this diagonal part, the more accurate class model will be. And above diagonal and below diagonal, if you get some values, it means that your model have also done some mistakes. If you are getting more zeros in case of multi-class classification problem, or even in this same table, if you are getting right here a 0 or right here a 0, then it means that your model made a single mistake. It did not make a single mistake. So basically confusion matrix just tells you that how accurately classified the predicted classes for the actual whatever model you have used, or how many mistakes that model have done. The second thing that you want to use for evaluation is classification report. So classification report tells couple of matrices for both your classes, like for 0 and 1, precision, recall, F1 score, and support. So basically, as you can see here, for precision, for 0 class, model has given us the precision is 0.77. So the more higher precision is, the more accurately detected or predicted that class by the model. And here you can see for 0 class, the recall is 86, which is a good sign. And for 0, F1 score is also higher, 89. So mostly if you are getting 91, 92, 95, then it means that your model has quite great performance for that class in case of precision, recall, and F1 score. And the same thing goes with the second class 1. You can see 84 precision, 75 recall, and at 79 F1 score. And here you can also see average or the total accuracy of your model for test data. So Classification report summarizes a model performance using key matrices like precision, that is the correct positive prediction, recall, that is the correctly identified actual positives, F1 score, that is the balance between precision and recall, and support, that is the number of true instances for each class. So basically it gives a detailed view of how well the model performed per class. Like you can see precision, recall, F1 score for each separate class, and also you can see average values or average accuracy. You can see average precision, recall, and F1 score. Okay, now let's implement these things. So we have the same data set that we are already using in this playlist. We have already done the pre-processing like encoding, the 3 columns like gender, department, education. Then we already seen how we can do trend test split. Now let's train a model. So I'm going to use logistic regression. So let me zoom in a bit. From Scikit-Learn, the first thing I have to do, I have to import from linear model, I have to import logistic regression. Okay, and the second thing that is important, that from matrices, now all the evaluation classes either for classification or for regression problems you have to import from matrices class. So from matrices import, since we are dealing with classification model evaluation, then you have to use confusion matrix. Now one thing you need to remember, that is if you are dealing with a regression model, then you will use other matrices like root mean squared error, mean absolute error, or R2 score. That we will see in upcoming videos, but let me import confusion matrix, classification report. Also you can do separately accuracy score, and if you want to visualize the confusion matrix plot, you can either use separately Python 2 module like matplotlib and Seaborn, or either you can directly use there is a class by the name of confusion matrix display. You can do also that part with this class as well. Now let me also import matplotlib library. It will help us in visualization. So pyplot as plt. Yeah, now let's create an object of our logistic regression model. Now let's also train. So call fit and pass your xtrain and ytrain. Now let's test our model. So predict on xtest data, and for xtest data we have to store these are ypred. Now for xtest, for each row the model will predict either 0 or 1, and that 0 or 1 will be stored in ypred. Now we have to compare this ypred with the ytest, because we want to do comparison between actual classes are this, and predicted classes by the model. So let me print first accuracy. So I can use directly accuracy function, and I can pass yTrue, yTest, which is the actual labels or classes, and ypred, predicted by the model. And then let me print classification report. So for classification report you can say like classification report, and you have to pass the same thing like actual and predicted, so that we can compare. So ypred, and let me do the same thing for confusion matrix, but either you can do like this confusion matrix. So here you have to write confusion matrix, pass ytest and ypred, and run it. So as you can see, the accuracy is 50 for that model. Precision, if I do not print, or let me just quickly cut this part from here because I don't like this view. Okay, so what I can do, I can pass. For now let me also correct this part. So let me cut this part from here, Control X, and paste it right here, Control V. So let me run it. and let me paste it right here. So here you can see if I add here a new line, that will be much better. So here you can see this is the accuracy of the model and this is the confusion matrix. Now here you can see the model is not performing well since we are using a dummy data and with a low sample like 200 records. But yeah, you can see you will get the confusion matrix in this way. I'll plot this a bit later, but these are the confusion matrix. For zero class we have let me also add a new line here. So for zero class, this is the precision, which is 50. Recall F1 score. Again, the more higher you get this value, the more accurate your model will be. And the same thing goes with class 1. And this is the average accuracy and average recall precision F1 score and weighted average. Okay. Now, if you want to plot this, you can also do that. So let me create a variable by the name of dist, then let me call this confusion matrix display. There you have to pass a parameter confusion matrix, but for that I need one thing more. I have to calculate confusion matrix and store it in a variable by the name of confusion matrix, and here I have to pass CM. And if you want this label to be displayed right here, you can also do that, but for that you have to use label parameter or display label. So this display labels will be equal to, now how to get that label? So we have a train model, basically not a model, logistic regression. There you can call labels, classes. So if you get that classes, it will automatically get there. Now let's plot this. So dist.plot, and you can also set some color like matplotlib.cm.blue colors. I want blues. Okay. So let me run it. One position 2 are given. There is an issue with this. The error is right here. We have to pass a parameter cmap. So cmap like this. Let me run it. So now you are getting the plot. Oh, not this one. Basically, write this one. So this is a confusion matrix, and this is the plot. You can see confusion matrix is not quite good for this model, but if you want to try some other model like decision tree, you can do in the same way. First you have to create an object, then train, then do prediction, then confusion matrix, score and classification report, and we have displayed confusion matrix. So let me run it. You can see decision tree is performing better than logistic regression. For actual 1, model classified 10 times 1, and for actual 0, model classified 0 9 times. But again here you can see model made 8 mistakes for actual class 0, and for actual class 1 model made 7 mistakes. So whenever you want to build a machine learning model, you will be using a data set. Now you don't know who created that data set, so there might have some missing values. As you can see in this data set, if you focus on annual income column, we are getting 2 missing values. One is this and one is this. So if you want to drop this missing value, you'll have to drop this entire row. So because of this single value, we are going to lose a lot of more values from more columns. So again, here we are losing a lot of information. And if you want to drop this missing value, you will lose a lot of information. So this is not a good way to drop a missing value from your data set. So instead, we have to fill that missing values so that we do not lose a lot of information because of that single value. Now in data set, we have 2 types of data. One is categorical and one is numerical. So if you are fetching a missing value within a numerical column, like in our case, annual income, then you have to fill the missing value either with mean or standard deviation. But if you have a categorical column, let's say this home ownership, and you have some missing value, then you can fill that missing value with most frequent value within the same column. Okay, now I am going to use the same data set, binary classification sample. So let me quickly show you that we have missing values or not. So you can call df.isNull method. This isNull method will tell you missing value, and then you have to call sum. So here you can see in salary we have 15 missing values, and in education we have 10 missing values, and location score we have 10 missing values. But salary and location scores are numerical columns, but education has categorical data. So we have to use two different techniques. Now for this Scikit-Learn provide simple imputer class. So from Scikit-Learn .impute, we have to import simple imputer. So from import simple imputer class. Now let me quickly run this cell. Now let's first fill numerical data. So fill numerical column values. So we have to create an object of simple imputer. So let me call it imputer1. So call simple imputer. Now here we have to pass a strategy. So since I'm going to fill numerical columns data, either you can use mean or standard deviation. So I am going to use mean. Now what does it mean? So if I am going to fill the 10 missing values for salary column, so first I have to calculate this entire column mean. So let's say after just let me quickly show you. Let me zoom out a bit and let me add couple of cells. So if I go to salary column like this and I call mean, you will get the mean. So this is the mean. Now we are going to put this value for all the 15 missing values. Okay, and if I go to location score and calculate the mean, this is the mean for location score. So we are going to put for all the 10 missing values for location score. That's why we are using here strategy mean. Okay, now let's apply this imputer1 on the two columns that we are going to fill the missing values. So you can call fit transform method, and here you have to pass both columns. So the first column is salary and the second column is location score. Now we have to also store the result right here. Okay, so now if I run and again let me show you is null dot sum. So now you can clearly see we successfully fill all the missing value with the mean for salary and likewise for location. Now let's fill the missing value for education. But if I show education column value counts, you will see that these are categories. So we have to fill it with mode or most frequent value. For example, if I just call mode right here, you will see the most frequent value. So in education, the most frequent value is bachelor's. So what we can do, so let's create another imputer by the name of imputer2, and let me call simple imputer, but this time strategy would be most frequent. Here most frequent represent mode, and then let's apply this on education column. So this is education, and let me call imputer2 dot fit transform, and let pass the column that we want to fill the missing value. So education like this. So now if I show the data set, this is the data, and if I call isNull method and sum, you will see that now we have successfully filled all the missing values using just simple imputer. Now one thing you have to remember about this technique, you have to focus, first you need to check the missing values. Whenever you are dealing with a data set and you see some missing values, then you have to find that the missing values are in salary column, numerical column or categorical column. If you have numerical column, then use strategy mean or standard deviation. But if you want to fill missing values for categorical column, now the categorical column could be gender, male and female, like in our case, gender, department and education. Then you have to use most frequent. If you have already a trained model, then how you can use that model for prediction? For example, if I want to predict for this data, let's say I have a car data like year 2012, kilometer driven 1000, fuel type diesel, seller type dealer, transmission manual, owner second owner. So once I pause this data set, the model must predict the price for the car. Okay, so for that, first you need to train a machine learning model. Now in previous video we have seen by using this car price prediction for scaling. So since the main objective and purpose of this video is to create a custom function where you can use a trained model for new data for prediction. So since we have already seen that how you can import data set, this is the data that we will be using for inference code. So in this data set, we have a target column by the name of selling price. And we have seen that this is a target column and this is a regression problem. Okay. And all the other columns like kilometer driven, fuel, seller type, transmission, owner and year are the input features. Right. Now, as you can see in this data set, we have fuel, seller type, transmission, owner. All these columns are categorical, so we have to convert it or encode it into numbers. And we also need to scale kilometer driven and year. Now we already seen in this playlist, so what you have to do, we have just scaled, we have just encoded all the 4 columns like fuel, seller type, transmission, owner. Now how you do encoding we have already seen. Okay, after that I have performed standardization for year and kilometer driven. Now you can see kilometer driven and year has values between the range of 0 and 1. So now we are ready. So after that we have done trend test split. We have already seen about this. Now after that I have trained a regression model which is giving 39 accuracy, and I have also trained a random forest regressor which is giving 50 accuracy. So we can use this model, this random forest regressor for new data. Now here let's implement prediction system. So first let me quickly import NumPy library, or even I don't know if I need it or not, but let me quickly create a custom Python function by the name of predict car price. Now this function will take here kilometer driven, fuel type, seller type and transmission, okay, and owner, like this. Now within this function, the first thing we have to do, we have to apply the same things that we have applied during training, like scalar, encoder and model. So for this new input data, we have to do 3 things. First, we have to scale this we have to encode this 4 values, and we have to scale these 2 values. But for this, we need to create a data frame. So here we can use pandas data frame function like this, and it takes 2 parameters, data and columns. So for data I am going to use a list of year. Let me quickly copy this, Control C, and let me paste right here. So this will be my data, and for column I can use like, so as you can see, this function takes year, kilometer driven, fuel, seller type, transmission and owner, And in first step we have to prepare a data frame. For that you can use data frame method. So you have to pass your all values and corresponding columns. So the first is year, kilometer driven, fuel, seller type, transmission and owner. Now the second thing that we have to do, we have to encode these 4 columns. Okay, for that we have already a trend encoder. So let me write here step 2, encoding categorical columns. So if I go to input data, my final data is this, our input data is this, and if I call fuel type or just fuel and seller type, transmission and owner, and let me also copy, Control C. Now let me call our trend encoder. We have already encoder by the name of encoder. Now this time you don't need to call for transform. Instead you have to call transform method, because this encoder is already trained on this 4 columns values, right? So here we have to pass again this entire data. Okay, so that was the first step that we have done during training. You have to also implement during production, or you can say inference code. The third step would be scaling. So what I can do, input data, and I can call the 2 column like year and kilometer driven, and then I can call scalar. We have already scalar. Again you have to just call transform method, and you have to pass year and kilometer driven, right? Now we are ready. So what we can do, we can train model. So the last step is predict model or predict by the model. Now we have to pass this entire data for the train model, and it will give us price. So call model. So we have already a train model by the name of model. So model will be equal to model dot predict, and you have to pass input data, and now this will return price. So as you can see, I have this example where I have 2012 year, 1000 kilometer driven, this fuel type is diesel, seller type is dealer, transmission is manual, owner is second owner. So what I have done, I have just called the function which is predict car price, and I have passed all my values. So this is the final function, again predict car price, and we are getting all the values. First we are creating a data frame, then we are encoding all the categorical columns, and we are scaling all the numerical columns, and then we are predicting by using the train model, and finally it will return estimated price. So let me run it, and once you run this cell you will get this result. So for this input, the model predicting the price, which is 373,589. It's mean 3,73,589 rupees. So let me pass another example, which is 2018, 43,000 kilometer driven, petrol and individual manual. Now let me run it and let's see. So you will get this price for this car. So you can see how we have learned and implemented that once you train a model or with some other files like scalar and encoder, then how you can use that things in product. So before understanding how we can balance a data set, we need to understand what is imbalance data set. Now for this video I am using another data, student score data. So load the data set. This is the data, and I have also removed some columns because these are irrelevant. So let me run the cell. Now you can see we have this data where we have a student with gender either male or female, part-time job, absence days, extra curricular activities, and so we have a lot of information like math score, history score, physics score, chemistry score, biology, and this is the career aspiration. So you can use this type of data set for career recommendation system or education or student recommendation system. So again, this is a supervised learning problem. Why? Because we have a target column and we have input columns. Now, is this a regression problem or classification? So let's check the target column. So if I go to career aspiration, because this is my target column, and if I call value counts, you will be able to see that we have some classes like 1, 2, 3, 4, I think total 15 or maybe 12 classes. So this is a classification problem, but since we have more than 2 classes, so it could be considered multi-classification problem. So this is the data set. Now you can clearly see that we have some classes with more records and some classes with lower records. As you can see here, software engineer has 315 records, business owner has 309, unknown 223, banker 169, and if you see writer, we have only 32, and for government officer we have only 61 records. So if you train a machine learning model on this data set, then the model will try to biased or focus on those classes that has more records. So it will ignore smaller classes. So this is not the good way to proceed with building a model. You need to properly this balance. Now there are 3 techniques for balancing a data set: undersampling, oversampling, and smart. So you can use another library for balancing a data set using by the name of Imbalance, which is also an extension of Scikit-Learn. But we can do the same thing with Scikit-Learn class by the name of resample. But you will not be able to do smart, but yes, we can do undersampling and oversampling. Okay. Now, how undersampling works and how oversampling works, first let's understand that. So in case of oversampling, if you have 2 classes, so what we do, we basically create copies of minority class until it becomes or equals to majority class in case of oversampling. In case of undersampling, what we do, we reduce the majority class. We remove rows from majority class until it becomes or equals to minority class. So in case of undersampling, we are reducing majority class, but in case of oversampling, we increase or create copies of minority class, as you can see. Okay. Now this is the data and we have to balance it. But before balancing, let me quickly train a random forest classifier to see that without balanced data set, how it gives its accuracy. So all the other classes are input and this is our target class. But you can see gender, part-time job, and activities has categorical data, so we have to encode them. Male, female into 0, 1, false, true, it's mean yes, no, into 0, 1, yes, no, into 0, 1, and we also need to convert this into numbers. Total 15 classes, so we need 15 numbers. So for that we can use encoding techniques like label encoder. Second thing, we have to scale numerical data. Because if we have larger value, then again model will bias to our larger value. So we have seen all those things, how you can scale and how you can encode categorical data in previous few videos. So let's first do encoding. So you're already familiar with the code. You have to import label encoder or ordinal encoder from preprocessing. Then you have to create a list of those columns that you want to encode. So in our case, we have gender, part-time job, activities, and career aspiration. Then you have to create an object. Now since I'm dealing with more than 1 class, so I can run a loop. So I just run a loop on this call. So one by one I'm getting a column, then I am encoding and storing in data set. So once I run it, you will see that now we successfully encoded gender, part-time job, and the other columns. Okay, now let's quickly do scaling in the same way using standard scalar class that we have already seen in previous video. Okay, but as I mentioned that scaling can only be possible or can only be applicable for numerical columns. Okay, so the numerical columns would be all these core columns and R's. So I have extracted all the columns, then create an object of standard scalar and then accordingly applied. So now you can see your data will be in the range of 0 and 1, and if you train a model on this data, it will give equal importance. Now before balancing, let me quickly do train test split and let me train a model so that we can see that before balancing how the model perform. So again, you already familiar if you have accessed this playlist Scikit-Learn for machine learning, how you can apply train test split. So let me run this as well. Now let's train a random forest classifier on this imbalance data. So from ensemble I have imported a random forest classifier, and from matrices classification report and confusion matrix, and I have created an object and also trained the model. These are the prediction. Again, we are already familiar with these things, and then accordingly I have printed confusion matrix and classification report. Let's see how the model perform. So as you can see, if you focus on classification report for each class, total we are dealing with 16 classes. You can see precision, recall, F1 score. But if you focus on this value, the overall accuracy of the model is only 50. So this is not a good model. So what if we do or we balance the data set? So after balancing the data set, we can see if the model could improve or not. But you can also see confusion matrix. Your model has a lot of errors. If you focus above diagonal and below diagonal, your model is giving you a lot of errors, misclassification. Now let's quickly do balancing. So you just need to import from Scikit-Learn.utils, you have to import resample. Now this is the class with the help you can either perform oversampling or undersampling. So resample needs couple of parameters like the data set and resample, number of sample, you want oversampling or undersampling. We'll discuss this a bit later, but also you need to pass random stat, which will be 42, and you also need to pass one more thing, that is sample. This will always be true. Now what does it mean? We will also see that. Now I would like to do in a better way. Like first I want to get all the unique classes. So how I can do, I can go to career aspiration, I mean target column, and then I can call unique method so that I can get all the unique classes. So if I print, as you can see, we have all these classes, right? Now let me also get a sub df for each class. So I can run a loop, a list comprehension, like for label in classes. Then I have to do some filtering. So df like this, if df target column equal to the label we are extracting, then this will be my df list or list of df. You can give it any name. Okay, so if I just print df list, it should be label like this. So as you can see, now we have a data, but it is a list, not a data frame. Now we have to pass by calling resample, but again I have to run a loop for sub df in df list like this, and here I have to call resample class, and this resample class need couple of parameters like my entire sub df sample will be true, and Number of samples, you want oversampling or undersampling. So I want oversampling, 315. What does it mean? Because if I just show my target column, as you can see, the maximum class is software engineer, which is 315. So in case of oversampling, you have to specify here the number of maximum class, and also random stat will be equal to 42, or you can give any value. And I can say that this is upsampled, df upsampled. So let me test this code. So you can clearly see this is the same code, by the way, but if I run it, df upsampled, now we have balanced data, but since this is a list, so I can call concat method and I can pass my df upsampled, and this will be my final df. So this is my final df. If I go to final df and call career aspiration and then show value counts, you'll be able to see okay, here I have to use 315. So let me rerun this code again like this. You will understand everything, just bear with me. And we already performed. So here you can see first we extracted all the unique classes, then we extracted our df list based on that class, and then we have passed by calling resample class our entire data that we want to balance. Okay, this should be replaced, not sample. Sometime I forgot, because when I use balancing data set for real project, then I use Imbalance library, not this resample class. Okay, and number of sample, I pass 315 because I want for now oversampling. Random state 42, and this is the list comprehension. Now one thing more, if I run this and show this, as you can see, now we have balanced data set. For each class now we have 350 because we generated for each class copies. So this is known as oversampling. Okay, but one thing more, as you can see, we have to reset this index. So what you can do, below this line of code, you can add this code, df.sample with fraction this, and you can pass, you can call reset index drop will be true. So now if I just show the df, now you can see we have from 0 the index. Okay, so we are ready to go with this data set. Now if I just copy this code, running code and testing code, and paste it right here. So in without balanced data set, we are getting 50 accuracy for the model. But as you can see, I think there is an issue. I think I forgot to run this cell, run test later. Yeah. Now I have to run this. So you can clearly see the model achieved 95. So this is the beauty and advantage of balancing data set. And if you are doubting based on this accuracy, you can also see for each class precision, recall F1 score almost 99, 94, 98, which is quite interesting and amazing. And you can clearly see confusion matrix. Now your model still doing some misclassification, but still you can clearly see now we have a lot of zeros. So in case of confusion matrix, as I already mentioned, if at the top of your diagonal and below the diagonal you are getting more zeros, then that model will doing great results. It means that it will not be doing a single mistake, but still you can see it has also done here an error here. But yeah, you achieved quite great results. Now for undersampling, what you have to do, sometime you need undersampling. For undersampling, just let me run zoom out. Let me run all the above cells so that we can also check undersampling. Run all above. Now here you have to just pass the number of minimum class. So I think the minimum class is this one, 32, because we are removing values or rows from majority class, so that it becomes to minority class. So 32. Let me run it, and if I show, now we have all class balanced based on minority. So sometime in with minority it will also give an accuracy. So without balanced data we have this, but if I run my model with undersampling, you will still get better result. So still it's improving. One of my favorite class in Scikit-Learn, that is column transformer. So column transformer is a class that is used to combine multiple pre-processing steps in machine learning. So whenever you are getting a data set, then in that data set you will be seeing a lot of columns like input and corresponding target column. Now before running a machine learning model and deployment, you need to prepare this data set. That is known as data pre-processing, right? Now in data set, as you can see, you will have some categorical columns like city, cough, and gender. So you have to encode before training the ML model, because ML model need numerical data or numbers. And also you will have some kind of numerical columns that you will have to scale between the range of 0 and 1 so that the model give equal importance. Now as you can see, you have to implement a lot of pre-processing steps like encoding, data scaling, or might be some missing values, so you have to use simple imputer by filling the missing values, or might be some more pre-processing steps. Now instead of implementing each and every pre-processing step separately, you can combine them by using this column transformer. Okay, but there is a main advantage of column transformer that you will see that advantage in this video at the end part. Okay, so here you can see we have train and test sets, and you are directly jumping into prediction system without doing anything, because you have combined everything like pre-processing, model training in a single pipeline. That is known as pipeline in machine learning, by combining multiple pre-processing steps including training and evaluation your model, right? So here we have imported pandas library and trend test split function that is used for splitting your data set. And from pre-processing we have imported standard scaler that is used for scaling data set, and one hot encoder that is used for encoding categorical data into numerical or numbers. Now this is the class that is imported from compose. Okay, so from sklearn.compose you have to import this column transformer, and we have also imported random forest classifier and its evaluation matrices like accuracy score and classification report, right? Now this is the data. Since this is a toy data, so we will use this data for column transformer so that we could understand how we can use column transformer for pipeline. Okay, now the first step I have done here is just encoded target column yes no into 0 1 manually. So here I have called target column by calling map method, and by mentioning that if you are getting yes, then convert it into 1, else 0. So as you can see now, in target column we have 0 1 for yes and no. Okay, now I have to encode gender, cough, and city. That is a step of pre-processing, and I have to scale age and fever. Now either I can do separately, but since we are using a column transformer, so first let me quickly do trend test split. As you can see, we have already implemented using trend test split by passing our input feature and corresponding target column. So these steps, these things we have already seen in previous couple of videos in this same playlist, Scikit-Learn for machine learning or machine learning with Scikit-Learn. Okay, now this is important, you need to understand. So what you have to do, if I just add a cell here, so you have to call column transformer, that is the class that you are using. I think yeah, let me just copy this and paste it right here. Now this column transformer need a parameter that is known as transformer. So this transformer is basically a list. Now here you can pass all pre-processing step like step 1, let's say scaling, and this will be a tuple. Step 2, like let's say encoding categorical column, and step 3, let's say filling missing values. So now this is important, you need to understand. In tuple you have to pass 3 things: name, that pre-processing step class that you want to use. Since we are using scaling, so I will use standard scalar class. And the third thing will be the feature or column that you want to apply this standard scalar. So we have this 2 column, edge and fewer. So this is the first pre-processing step that we have passed to column transformer. Now here you can give any name like numerical column, or let's say you can give scaling. And the second step, you have to pass another pre-processing step if you have, let's say in our case we have encoding. So here you have to use one hot encoder or label encoder, whatever you want to use. There are 3 classes for encoder: label encoder, one hot encoder, and ordinal encoder. And the third thing will be the columns or feature that you want to encode. Since we have these 3 columns, so you have to pass these 3 columns. Okay, so here what I want to teach you is basically the step that you are combining. Let's say we have another step, missing values, and let's say we have imported simple imputer. We have already seen about it, that is used for filling missing values. Let's say I have column edge and I have another column city where I have some missing values. So I'm also setting that simple imputer. So the main idea is we are combining multiple pre-processing steps into a single pipeline. Now you can store this in a variable, let's say by the name of pipeline or column transformer. Now as you can see, since I have separately done these things, like I have taken all the categorical features and numerical features and created a list accordingly. Then I have this column transformer by calling transformer parameter and by creating the 2 steps. Okay, like first I'm going to encode number of features that are numerical features, and then I'm going to encode categorical features. And once I create object, then I'm going to call fit transform method, and by passing my input xtrend and xtest accordingly. So once you run, now you can see in single one line of code you have applied 2 steps. There might be multiple steps like 4 or 5 steps when you will be dealing with some real or bigger project or complex data. Then you might be dealing with multiple pre-processing steps. As I mentioned that I'll show the main advantage in this video at the last part, but since you can see we have created this object and apply accordingly. Now what happened, you will get a NumPy array of your entire data set where you have done everything like scaling, encoding, filling missing values, or whatever you have pre-processing steps. Now you can use this new variable for training and testing. So now you can see we have created random forest classifier and run it on xtrend transformed and ytrend, and then we have evaluated. Since this is a dummy data, so you will not be getting much better result, but yeah, we are just learning column transformer. Now this is important. This is the code since you already train a model. Okay, so if you have watched previous 2 or 3 projects, I have implemented 2 to 3 end-to-end ML projects. You have seen that whenever you deploy this model into your app or website like integration, and there you will be getting new user data. So whatever you have done before training the model like encoding, scaling, you have to repeat all those pre-processing steps during production or deployment. So here let's say for now consider that this is the website where we are passing the train model, train column transformer and new user input data, where we have a patient age with 40, that is female, that is the fever, she has mild cough, and she's from Mumbai. So this is the new data that we are going to use COVID prediction by using our trained model. Now we have called the function by passing the model, column transformer, new input data, and we are getting right here. So first what we have done, we have just created a data frame of the new user input data. Now here you can see, instead of using separately encoder, scalar, as we have previously used in couple of projects, here you can use one line of code just using the train column transformer and transform your input data. Now here what does it mean? It means that you are repeating the same steps that you have done before training, because this is important, but you are reducing your code and saving your time. But the main advantage of column transformer is to use one thing for everything. Now this column transformer need another class that is known as pipeline, that we will see in the next video, that it will further reduce this code into a single line. Okay, so here we have transformed the data, like we have done pre-processing for the new input, then we have predicted by the model, and this will be the prediction. If it is 1, then it will be COVID, otherwise it will be no COVID. So once you run here, you will get the result. We have already seen that how you can use column transformer class for combining multiple pre-processing steps. But if you want to combine multiple column transformer into a single line of code, then there is another class that is known as pipeline. Let me repeat, this is important, you need to understand. Column transformer is used for combining multiple pre-processing steps like encoding, scaling, filling missing values. But what if you have, let's say you created 3 column transformer, for encoder separately, for encoding separately, for scaling separately, for missing value separately. Then you can combine all those 3 column transformer into a single pipeline, including model training. So let me show you. So if you have watched the previous video, then you might be familiar with the flow. But as you can see, we imported trend split, then all the standard scalar and one hot encoder from pre-processing, and column transformer from compose that we have already discussed previously. And this is the class that we are going to implement in this video, that is pipeline. So you have to always import pipeline from pipeline class from Scikit-Learn. And this is the same model that we have used previously and same matrices. This is the same COVID data set where we are going to classify that the patient has COVID-19 or not too. Okay, so as in this data set, you can see we have age and fever numerical columns. So you have to scale these 2 columns by bringing their values between the range of 0 and 1, so that the model give equal importance. And gender, cough, city are categorical columns, so you have to encode all these values into numbers so that ML model can understand it. Okay, so manually, as we previously already done, target column yes to 1, no to 0, as you can see. Okay, then we have done trend test bit. This is the part that you need to understand. As previously we have seen that you have to call column transformer, and calling transformer, then this is the first step where we have passed 3 things like the name for that step, the class that is used for that step like scaling, so we have used standard scalar, and the columns in your dataset that you want to scale, so we have these columns, age and fever. Then we have categorical, we have used one hot encoder, and we have passed all the categorical feature like gender, cough, city. Now you can also create, and we have stored this in pre-processor variable. So you can create more column transformer step. Let's say we have another by the name of preprocessor 1, where we have, let's say, missing value step. So let me remove missing values. Then let's say here we field on this column. So now we have 2 column transformer. So I'm going to combine this 2 column transformer, including my model. So here I can just copy this and paste it right here. So here you can see we have called pipeline, and there it's get a parameter by the name of steps, and you have to pass a list of steps. So this is the first column transformer or pre-processing step, and this is the second, so you have to change the name accordingly. Okay, and we have also passed another third step, that is model training or classifier. Okay, for now let me just remove this. So I just wanted to show you that yes, you can combine multiple preprocessor steps or even column transformer. So now finally we have only these things where we have the preprocessor, where we have done all the preprocessing steps, and model random forest classifier. After that we have just called pipeline, because finally we have this pipeline, and then pass our training data. So as you can see, this pipeline has some pre-processing step. First, column transformer, where we have first pre-processing step, that is numerical, or you can say scaling. The second one is categorical step, where we have used one hot encoder, and finally we have combined these two pre-processor, or you can say column transformer, with random forest classifier using this pipeline. Okay, and then I have tested pipeline. You can see the same result. Since this is a dummy data, so you will not get bad result, but yeah, as you have seen that now you have final only test things. Now as I mentioned in previous video, that you will see the main advantage of column transformer with pipeline again in deployment or integration part. So once you train a model, then you have to bring that model into a real world so that user can access and use it. Now there you have to repeat the same steps that you have done for training, like encoding, scaling, filling, missing filling values, training, all those things. Sorry, for training you have to use prediction. But so it means that you have to repeat all those things. So you will report all those things again, but this time you don't need to do a lot of code. One line of code, because you have pipeline and it has everything. So as you can see, this is the same function where we are passing the pipeline and new user data. We have a new patient where it has 40 age, female, with cold, cough mild, and from Mumbai, and we are passing our train pipeline and this new patient data we are getting right here. First we are creating this new data, a data frame, and then we are just predicting. Now you don't need to do encoding, scaling, pre-processing. Pipeline will internally handle. So this is the main advantage. So in this video we are going to discuss and implement deep learning with Scikit-Learn. Now since Scikit-Learn is specifically designed for machine learning problems, but there is a class by the name of multi-layer perceptron that can help you to implement deep learning logic. Now if you are familiar with deep learning algorithm architecture, so the first algorithm that you will be learning in deep learning is neural network. Now in deep learning we have input layers, hidden layers, and output layers. All the data will be passed from input data, then hidden layers, and finally in output layer you will be getting your output. Before discussing this, let me quickly show you the data set that we will be using for this problem. So basically we are going to detect breast cancer. So this is a textual data where we have this diagnosis target column where we have two classes. Benign, it's mean that there is no cancer, and malignant, it's mean that there is a cancer, and all the medical features for breast. Okay, so there are a lot of features that are related to medicals. Now this data is already pre-processed, we don't need to do a lot of pre-processing, but before implementation let me quickly explain you what is neural network. Now in simple terms, neural network is a deep learning architecture or algorithm that works like human brain. Okay, now human brain works if you get some input from your body parts, or you can also say receptor. Then first it will be passed to your brain will process it, and finally it will generate output accordingly. For example, if you touch hot water, then you will jerk your hand backward because your brain will command you that it is hot or it is cold. Okay, so hand is your receptor or input, but there are a lot of receptor like eyes, nose, ear, and touch. So based on that receptor you will be getting input, and that input will be passed to your brain will process it, and accordingly it will generate output. Okay, so in the same way deep learning model works. It will get all the input columns or input features from input layer, and then it will be passed to hidden layers. Now hidden layer could be 2, 3, you can make it more and more deep, and finally it will generate output right here. Now here between input and hidden layer there will be some matrix multiplication, weights and biases, but the main idea is that from input layer it will get all the input features. Like in our case we have all these input features, okay, and it will be passed to hidden layer. There will be activation function, it will generate output between the value of 0 and 1, and finally you will get the output, and the output layer will predict the class basically. So in our case we have two classes, malignant and benign, cancerous or not cancerous. So the output layer will predict at a time a single class, okay. So this is the main idea behind neural network. Now let me quickly do imports. So imports could be repetition, because we have seen previously in a lot of videos, like you have to import pandas. From model selection you have to import trend test split, which is used for dividing your data set, and for pre-processing you need to import label encoder, because we have to import diagnosis target column two values which are benign and malignant into 0 and 1 accordingly, okay, and standard scaler for scaling on the input features between the range of 0 and 1, so that model give equal importance to each value, okay. Now this is the class neural network. From neural network you have to import multi-layer perceptron classifier, okay. So this is the deep learning model that is used for classification problem, and once you train this classifier, then you have to calculate or check its performance. Then you need accuracy and classification report from matrices. So let me quickly paste the data set. So this is the data set, breast cancer. You will get in video description this data set, and let me show you how it looks like. As you can see, this is the data where we have 31 input features and one target column. So this is a binary class classification problem. Now we need to do trend test split, but before trend test split we need to convert or encode M and B, which is malignant and benign, into 0 and 1 accordingly. So you can use label encoder. So you have to create an object, as we have seen many times in previous videos. Then you have to call fit transform method and pass your target column. So if I just show you DF, now here you will see 0 and 1. Now we need to do trend test split so that we can properly divide our data into 80% and 20%. So here you can see we have all input features and corresponding target column. Then we have called trend test split, where we have passed X and Y. So finally we have X trend, X test, Y trend, Y test, okay. So once you run you will get 80 and 20% data, okay. There is an issue, I think I forgot parenthesis. Now before training multi-layer perceptron, if I just show you X trend, these are all the input data, which is 80%, and if I show test, these are again all the input data but 20%. Now the one thing I would like to do is scaling. We have to scale all this data. Now what is scaling? We have already seen in previous video in this sample list. For that you use standard scaler or min max scaler. So basically you create an object of standard scaler and then again call fit transform on X trend and transform on X test. So if I just show you X test, now this time you will be getting an array where you have scaled values between the range of 0 and 1, okay. Now let's train deep learning model, okay. So you have to call multi-layer perceptron classifier. Now since multi-layer perceptron classifier takes couple of parameters like hidden layer sizes, max iteration and random stat. Now if I just show you, in deep learning you must have input layer, and in each layer you must have neuron. This circle represent a neuron, okay, a neuron, or you can say a cell. So neuron could be considered a single column in your data set, a single column, single value. So this is first neuron, this is second neuron value, and this is third neuron value. So since we have 31 columns, so in input layer we must have 31 neurons. Now in hidden it depends on you. You could set 500, 1000, it doesn't matter. Okay, but here input layer will be automatically considered by multi-layer perceptron while training, but for hidden layer you have to specify how many hidden layers you want. So here we have passed 100 neurons. We are saying basically to this multi-layer perceptron that for first hidden layer we will have 100 neurons, and for second hidden layer we will have 50 neurons. If I just want to add third hidden layer, then I can say that again 50 neurons. Okay, but for now I just want to go with 2 hidden layers. And since in deep learning you might have heard that deep learning could be trained for multiple epochs, so here 500 means that I want to train my model 500 times. So each time it could produce and perform well. Okay. After that, once you create an object of multi-layer perceptron, then you can call multi-layer perceptron.fit and pass your 80% data. So as you can see, now you can test or you can check the performance of your multi-layer perceptron by calling accuracy score and classification report. So here you can see, let me just paste. We have called prediction for test data, and once we get all the prediction for test data, then we are comparing this predicted with actual data. So this is actual test data and this is predicted test data in accuracy score and accordingly in classification report. So now you will be getting that the model has performed 97 accuracy. It's mean that our model is performing well, and for each class benign or malignant, you are getting precision, recall, F1 score which are almost 98, 99, which is good. The more higher values you are getting, it's mean your modeling performing well, but overall you can see the model is performing very well. Now let's quickly create a detection system so that we can check for new data how the model performs. So I have this new data np.array where I have created 31 values because I have 31 columns. So this could be first medical parameter for the breast cancer detection, like this one. If I just show you, this is radius mean, then we had texture mean, parameter mean. These are all the medical parameters and some test and trials parameter values. Okay, but yeah, these are all the 31 features for new patient, and then we have this new sample. Now since this is a single D, so you have to make it 2D. For that you can use a reshape. So new sample dot reshape 1 -1 will make it 2D. Okay, so if I just show you how it looks like, the new sample, now this, as you can see, this is 2D because our model needs 2D data. Now since we need to scale this data as well, so we already have a scalar. So scalar.transform new sample, and finally we have this new sample. Then we have a train model which is multi-layer perceptron, then call predict and pass your new sample. So you will get prediction. Then we are checking if the prediction equal to 1, it's mean it's malignant. It's mean that the patient has a cancer, breast cancer. But if it is 0, then it's mean that it's a benign, there is no cancer. So once you run malignant, so based on this patient details or parameter related to breast cancer, the model is saying that the patient has malignant. I have another record taken from Wisconsin dataset, diagnose B's section. So let's say for this the model is saying benign. So you can see, you can also implement. So again we are going to implement multi-layer perceptron. You can do the same thing with images. Now before understanding image, we need to understand the dataset that we are going to use. So we are going to use a built-in dataset where we have images and we have 9 classes. So basically it's a multi-class classification problem, 0 to 9. So we are going to classify digits within image. As you can see, if you want to ask the model by passing this image that what we have in this image, the model will say that you have 8 in this image. So that is known as image classification. Okay, but the first thing for beginner, what is image? Basically image has 2 definitions. Image is a matrix where image could be considered a combination of rows and columns. So this is first column on 0 index, second column, third column. So total we have 27 columns for this image, okay, and we have 27 rows. So this is a matrix by 27 width and 27 height, or you can say 27 rows and 27 height, okay, or columns. But in image, basically we have some values. These values are nothing but pixels. Pixel is basically a tiny box or block that represent image color, contrast or color display, okay. Now as you can see here, we have this image where we have 3 digits, but we have a lot of 0 in empty areas, and the moment we see some color, then we have increased the values. So basically when you get an image, then you will see pixel values, and those pixel values will always be between the range of 0 and 255. 0 represent no color for that image, and if you get some higher value like 100, 150, 200 until 255, it will represent some color for that image. Now if you are dealing with colorful image, then that color will have 3 channels, red, green, blue, RGB. But since this is a built-in data set and it's a gray type images, so gray type images has only 1 channel, okay. So the main idea is image is nothing but a collection of pixels or collection of rows and columns, and pixel is nothing, it's some number or values that represent color for that image. So as you can see there, we don't have any color or some kind of object, then it will represent mostly 0. But the moment you get some color for representing 3 digits, you will get higher values, okay. So again, if you have seen the previous video, then we are going to repeat a lot of things, like you have to import from neural network multi-layer perceptron classifier, because this is the class that is used for deep learning. And I have discussed a little bit in previous video that how neural network looks like and how it works, okay. So basically there we have inputs, input layer, hidden layers and output layers, and how pass the data, okay. Then matplotlib, so that we can also visualize some images, and this is the data. Now there is in Scikit-Learn you will have a class by the name of datasets. Now this dataset have some built-in classes. If you want to process Scikit-Learn, then you can get a lot of datasets from this datasets class. So this is the data we are going to use, load digits, and model selection, trend test split, and accuracy from matrices. So here load digits, we have stored this. So if I run it, this is the data. You might be confused how it looks like, because this is already pre-processed. Now here data, basically an array where we have some image pixel values, okay. This is first image, okay, and this is the first row for that image. This is the second row, and this is the third row, until so on. And we have target where we have 0 to 9 classes, basically the digits, okay. You can see more details as well. And if you want specifically an image or all the images or all the data sets, then target names has an array where you have 0 to 9 classes, total 9 classes, and all the images, these are the all images. So this data is already pre-processed. So let me quickly do trend test split by passing digits dot data, because I'm interested in basically there will be a class. I just show you this data and digits dot target classes. So now I will have finally my trend test split. So if I run it now, let me quickly show you randomly an image from the dataset. So I want an image on index 10 from xtest with corresponding target name. Then I have used matplotlib imshow method that is used to display images within the notebook, and accordingly I have set labels. So if I run, as you can see, this is an image. Since this is a grayscale, so its resolution will not be okay or not be good to be shown everything. But yeah, this is an image where we have 2. So you can see this is 2. Let me run it again on, let's say, index 15. So this is 1, as you can also see right here, 1. So yeah, these are images basically, and each image will have a number or digit between 0 and 9. Okay, after that I have set multi-layer perceptron like previously we have done. You have to set hidden layers, where I have set only 2 hidden layers with 64 neurons, and I want to train this model 300 times. So this could be known as epochs. Now for deep learning model implementation, we have another library that is known as Keras or TensorFlow. But yes, if you are dealing with some basic classification, then instead of Keras you can also do with Scikit-Learn using this multi-layer perceptron classifier. Then we have trained, and then we have printed the accuracy score for this multi-layer perceptron classifier. So let's see. So 97, it's mean that the model is doing a great job. But I am going to create a detection system. So what I have done, I've just called numpy.random.randint, and I have passed my entire test data. So each time randomly I'm getting an image index, an entire image. Then I'm also getting the true class. Then I'm calling model.predict, and I'm passing entire data, but only those images that I have taken randomly. So finally the model will predict the digit for that random image. So if I just print predicted label, so the model predicted 4. Now I want to properly display this image, so I can use matplotlib library. So again I have passed the image and with true label and predicted label. Let's see. So the true label is 4 and model is also predicted 4. So it's mean that model correctly classified this image. And in the same way I have passed another random image. So 1, model also predicted 1. Let me rerun so that we can pass another random image, or let me just copy Ctrl+C and let me paste right here. So random image, true label is 4, model is also predicted 4. So you can see for MNIST dataset, the model that we have trained from Scikit-Learn correctly classifying each image. So you have seen a very basic introduction to image classification with Scikit-Learn. So if you are going to use image classification with low data like 300 images or 500 images, so you can go with Scikit-Learn multi-layer perceptron. Okay. Today we are going to implement a heart disease prediction system, but the main objective of this video is to learn how you can use functional transformer in Scikit-Learn for improving your model performance. Okay, so the main goal is to train a machine learning model without pre-processing the data, such as scaling data set, data distribution, normalization, and then we will see that how the model will improve if we pre-process the data set, like using functional transformer. Now we have 3 types of transformer, like log transformer, square transformer, square root transformer, reciprocal transformer. So we will implement all these transformer, but the main question is why we need functional transformer and what they do actually. So basically when you get a data set, like we are going to use this heart data set, I will share this data in this video description. So basically we are going to classify that the patient has heart attack or not, okay, by giving some medical features of that patient, like patient age, sex, CP, test, BPs, cholesterol, and all those medical input features. Okay, but as you can see, we don't know how the distribution could be for age column and sex or test BPs. Now in data science, there you might have heard and seen data distribution. So basically data distribution are 3 types mainly. Whenever you get a data set, it could be in these 3 types, like normal distributed data, which is good for any machine learning model, but always you will get data in a form like left skewed or right skewed. Okay, so as you can see, this is a right skewed and this is left skewed. So if you get such data, then your model could be perform poorly. So let me quickly show you the distribution of this data by plotting it. So what you can do, you can just call dataset and by calling histogram plot. So once you run this plot, you will be able to see for each column data distribution. Basically, let me add here fig size where I want 12 by 10 inches, and you can add beans will be equal to 20. Okay, so now let me run it again. Now you will see the complete distribution plots for each column separate. So here we go. Now as you can see, this is each column and it's almost normally distributed. Not completely, but we can say that the value for each column could be normally distributed. Sex is a binary, so we could not consider it. CP has 4 values, it's again categorical, we could not consider. But yeah, this column test BPAs is a numerical, and you can see it is right skewed, mostly right skewed, not completely but mostly right skewed. So we have to bring it like normally distributed. Okay, as I have mentioned, normally distributed data plot looks like this, and model needs such data. And also you can see cholesterol is right skewed, and this one, as you can see, this column, I don't know exactly the name what it could be, but yeah, it is left skewed. And here old peak is also right skewed. So what we have to do, we have to scale this data. We have to bring all the data as a normal distribution so that the model could perform well. But before that, let me train a model, without pre-processing. So first we need to do train test split. So df.drop target column on axis 1. So all the input columns will be stored in X, and Y will be equal to target column. So we expected all the input features as a X and corresponding target column as a Y. Now we need to do train test split, as we have seen in this playlist many times. So from Scikit-Learn model selection, you need to import train test split class. Then you need to create 4 sets, which is xtrain, xtest, ytrain and ytest, right? Then you need to call this train test split class, and you need to pass all your input features, corresponding target with test size 0.2 and random stat could be photo. So what does it mean? It means that all the input features, 80% data will be stored in xtrain and remaining 20% data will be stored in xtest. And from y target column, 80% data will be considered as a ytrain and remaining 20% data will be considered as a ytest. Okay. Now let me quickly train logistic regression for binary classification, for heart disease prediction. So from Scikit-Learn linear model, you need to import logistic regression. Okay, now we need to create an object like model logistic regression. Now we need to train logistic regression. So model.fit by passing our input feature 80% data and target column 80% data. Okay, now we need to test the model. For that we need to do some prediction on test data. So predict by passing 20% test data. Now we need to do comparison. So for that you have to import from Scikit-Learn matrices accuracy score so that we can check model performance. So here what you can do, you can call accuracy score by passing actual data, which is ytest, and predicted data, which is ypred. So here basically we are going to compare actual data versus predicted data so that we can check model performance. So you can see logistic regression is giving, okay, it's basically, I have to rerun this complete cells again like this, and let me run this as well. Okay, and now let me run this training model. So for the data set, logistic regression has given us almost 78 accuracy, which is good, but you can see this is not a good performance of the model because we did not properly pre-process this data set, like performing scaling or other pre-processing steps. But you can also perform model performance. You can improve model performance with the help of functional transformer. So as you can see, modeling without pre-processing is 78. Now let me use functional transformer. So we have already X, which has all the input features. So we need to bring the data as a normal distribution. So what you can do, from Scikit-Learn dot preprocessing, you need to import functional transformer. This is the class that provide all the transformer like like log transformer, and you can also create your custom functional transformer. So let me create log transformer, then you need to call functional transformer. Now functional transformer need couple of parameter like function, this function, where I am going to pass log transformer. So let me import numpy. You will understand everything. So here I can pass np dot log 1p. So log 1p is basically the transformer or function transformer that I am using for bringing the data to normalized form. Okay, and there is another parameter validate. You can make it, so by default it will be false. Okay, that is coming with functional transformer. Now finally we have an object as a log transformer. Okay, so what we can do, we can apply on our entire data set, or you can apply on X. Okay, so I can say X transformed, then I can call this log transformer, and then I can call fit transform method, and I can pass my X because my all input feature data has been stored in X. So now if I show you X transform, it will be a numpy array with scale data. Scale in the sense like functional transformer will do some mathematics internally, and it will try to bring all those numerical data to be normalized if it is right skewed or left skewed. Okay, but let me properly show a data frame. I can say xdf, then I can call pandas data frame method, and I can pass my this X transform data. So if I just show xdf, you would be able to see now a properly data frame. So as you can see, this is a properly data frame, but let me also add columns. For that I can use column parameters, and here I can get columns from X, right? So now you can see this data, but let me plot all the columns so that we can check and we can compare. So let's see. Okay, one more thing, let me add here fig size which could be 12 by 10 inches, and means could be 20. So let me run it again. So now as you can see, initially this is after using functional transformer. But if I just show the initial plot for age, as you can see, we have our data is mostly, as you can see, like 40 and 60. Mean could be 60. So it's already normally distributed, but you can also check this test BPs. It's right skewed. But after applying log transformer, as you can see now it's mostly right, mostly normally distributed. So what log transformer did, log transformer tried to make this test BPs as a normally distributed. Now if you train a model on such data, it will further improve. Okay, and you can also see cholesterol is now mostly, you can say not completely but mostly normally distributed. Initially it was as you can clearly see, it was completely right skewed, and also you can check this is also left skewed. So if we now after applying column transformer, you can functional transformer, you can clearly see it's mostly normally distributed, and there is no changes with it, but maybe a little bit improvement we can see right here. But yeah, you can see, and also we have seen more improvement in this old pick, because if I just show initially old pick was almost, or you can say completely right skewed, but after applying log transformer, it tried best to make it normally distributed. Now finally we have this new data. So what we can do, I can just call this code, let me train model right here, and for that I need to do some train test split again. So let me copy this thing, Control C, as you can see, and let me paste it right here. So here I can pass only XDF because this is the data that I'm going to use for training logistic regression again. So let's see what happens. So as you can see, the model is improved to 80%. Without applying functional transformer, the model has given us 70 or 78. But after applying functional transformer, we improved our model to 80. Now you can also do custom transformer. So if I just copy this code and paste it right here. So let me create here a custom Python function by the name of custom transformer, and it will get X. And first I'm going to apply square transformer. So square is very simple, just you have to take square of the value. So return square like this. So now instead of applying log transformer, I can call this custom transformer right here. So now let's see that how we can improve with square transformer. So it's in running. So let me show you the plot. So it improved a lot. It improved a lot age. It make it completely normally distributed. There is no changes or improvement with this column by applying square transformer, but you can see it also improved this one. So we have a lot of improvement with this column. Yeah, so let me train again. So let's see what happens. So we get the same, but still you can see the data could be improved. Now let me try a square root transformer. For square root, what we need, we basically need only np dot square root, and you have to pass x. So let's see. As you can see, it's in running. So you can make custom transformer as you want. So you can clearly see with square root we have improved age, also this rest BPS. There is no improvement with this column, but a little bit improvement with cholesterol, and also we have a lot of improvement with old pick. So let me train again the model with this, and let's see. So with square root transformer we also achieve FG accuracy, which is good. So you can try, you can make changes, and finally you can select the best one. Now let me try a reciprocal transformer. Okay, so for reciprocal transformer you can use this formula like this, and then you can divide x on 1 divided by x. So this value is based on research. Okay, you don't need to worry about it, but yes, you can also apply reciprocal transformer as a custom functional transformer for making the data normally distributed. So there is a little bit improvement we can see with reciprocal, but yes, log transformer and square root transformer could be a good choice for this data set. So let me train the model with this. Now in this video again we are going to implement another Scikit-Learn class for data distribution. So if you have a data which is not normally or Gaussian like distributed, and if you want to perform well on this data by your model, then we have to do some pre-processing and feature engineering using different kind of classes. So today we are going to use power transformer, and it has two types like Johansson and Box-Cox transformer. Okay, so any transformer like we have seen in previous video, functional transformer that are actually used for if you have data like right skewed or left skewed or not normally distributed, and once you apply that transformer, it could be functional transformer or power transformer, then it will make it that data normally distributed or Gaussian like distributed. So power transformer are basically used to make the data Gaussian like distribution. Okay, now before discussing, let me quickly show you the data set that we are going to use for this problem. So we are going to use this cement data set where we will be predicting strength of cement based on that cement age, some chemical features like fine aggregate, coarse aggregate, super plasticizer, fly ash, how many water was mixed while applying that cement, and the cement value. Now these are some chemical features, but basically we are going to predict strength. Now in strength we have some continuous value, so it is a regression problem. So since you can use all these input features, but for now let me quickly get those features that I am interested in. Let me quickly paste here. So what I have done, I have just taken cement column, water column, and edge. These are my input features, and this one is my target column. Then I have done trend test split as usual. So let me run it. If I just show the new data set, you will see this. Now since these are input features, we need to check this feature distribution. So you can use histogram method with fixed size, or you can say plot with fixed size 12 inches by 10, and you can set bins width to 20. So if I run it, you will see these 3 columns are 4 columns distribution. So you can see cement could be considered normally distributed but not thoroughly, but you can see this is not completely, but we can say that it could be right skewed. As you can see, right skewed seems like this. Okay, and water is already normally distributed somehow, and strength is almost normally distributed, but you can see it could be considered right skewed, and age data could be considered completely right skewed. So now let's train a model without applying power transformer. Okay, so what you can do from Scikit-Learn dot, since this is a regression model, so we will use a regression model. So from linear model you can import linear regression, or you can use any other regressor. Okay, either random forest regressor or support vector regressor, but let's see what we get with linear regression. So let's create quickly object, and then we need to train this model by passing our xtrain like this, xtrain and ytrain. Okay, and then we need to do prediction. So ypred, then you need to call model.predict and pass your x-test data. Now since this is a regression problem, so from Scikit-Learn dot matrices we need to import R2 score so that we can check model performance. So here R2 score, and we have to pass actual data, which is y-test, and predicted data, which is ypred. So for this data the model is predicting 50% accuracy. Now let's apply column transformer on this data. Sorry, power transformer. So power transformer has 2 types, Johansson and Box-Cox. So let me quickly implement Johansson. So what you have to do, from Scikit-Learn dot preprocessing, we need to import power transformer. So all feature engineering and transformer classes or data preprocessing classes you will mostly import from preprocessing. Okay, as previously we have seen column transformer, functional transformer, and all the encoder like label encoder. So all these classes you have to import from preprocessing. Now so we need to make the data Gaussian like distributed by using Johansson transformer. So let me create an object transformer, and then call power transformer, and we need to pass there is a parameter by the name of method, because it has 2 types. So which method you want to use? I want Johansson. Now Johansson and Box-Cox were two scientists who discovered this method. So Yo Johnson, you have to exactly type this spelling, and now we need to transform extern transformed and transformer dot fit transform, and we need to pass extern, and we need to do the same for x test. So let me control C and let me control V, and this time it must be test. So here we also need, here we can only use transform, and we need to pass x test. So if I just show you x test, yeah. So as you can see, now it's a numpy array, and internally whatever mathematics this Johnson power transformer use, it will bring that data, or it will try to make it normally distributed or Gaussian like distributed. Okay, so and let me now show you the distribution. For that, first I need to make a data frame. So x trend transformed df, then I have to call pd.dataframe method, and I have to pass this x trend transformed, and also you can set columns by passing xtrend.columns. Okay, so if I just show xtrend transform data transformed df, you will be able to see this data. Okay, this is now a data frame, but I want to show its plot. So fig size will be equal to 12 inches by 10, and beans could be considered 20. So let's see. So as you can see, if I just show you initial plot, cement was right skewed, not completely, but in some point it could be considered right skewed, and you can see strength could be a right skewed, and edge was totally right skewed. But after applying your Johnson power transformer, now you can see we have a complete Gaussian like distribution for cement and also for water, and you can see we have a lot of improvement in edge. So for all these three columns, the model, or you can say your Johnson transformer, tried his best to make them Gaussian like distribution from right skewed or left skewed. Okay, now let's train model on this data. So what I can do, I can simply I can pass this code using the same model, logistic regression, but while training this time we have passed xtrain transform with ytrain and xtest transform. So initially we were achieving 50 accuracy for linear regression, and let's see this time after, as you can see, we improved a lot. We improved almost 17. So you can see how you can improve your model with such pre-processing or feature engineering classes like functional transformer or power transformer. Now since, as I mentioned, that we have another transformer box cox, so if you want to use that one, then you can say box cox. So basically they do the same thing, but there is a little bit difference. So if I just show, as you can see, now we have, and let me train it again. So you can see with this we achieved 67.15. So if I just check your Johnson, let me control Z, like this, and let me also call, sorry, control Y, like this. Now if I run and if I rerun, so currently you can see 67 and 15 for box cox. So for you Johnson we are getting 67 and 19. So it's mean your Johnson is performing better in comparison to box cox. Now there is a difference. When to use which one? So if in your data set you have a combination of positive and negative value, that in real world you will mostly get positive and negative values, then always use your Johnson. Okay, but if you have only positive data, then use box Cox. And what is the use of box Cox? So we can use U Johnson's because we don't know we could have positive or negative data. So always use U Johnson's. You don't need to use box Cox. Okay. And if you want to see the difference, you can read these things. I have created this with ChatGPT, so you can also see the difference between U Johnson and box Cox. So from this video onward, we are going to start NLP with Scikit-Learn. So whenever you will be getting sometime textual data like sentiment analysis, text classification, or even audio data, now how to deal and how to train an ML model on that data and how to pre-process textual data, for that Scikit-Learn provides some classes and functions. So in this playlist, for upcoming 5 to 6 video, we are going to start NLP with Scikit-Learn. We will mainly focus on those classes and functions that are specially designed for NLP problems by Scikit-Learn. Okay, so for this problem, we will be using this data set, which is actually IMDb 50K movies reviews data set. As you can see, we have two columns, review and sentiment. In review, you will have all the reviews left by people for that movie. Let's say there is a person who left this review for movie that this movie was absolutely fantastic. Now we will see, once you pause or feed this document or review to your ML model, then the model must be able to predict either positive or negative based on this review. Okay, as you can see, we have another document, a complete waste of time, very boring plot. So here you can clearly see the person is showing negativity. So once you train a model and you feed in future a new input or text or review, then the model must be able to predict accordingly either positive or negative. So we have binary classification problem. So as you can see, this is a textual data and this is known as NLP, or you can say natural language processing in data science or AI. Whenever you are dealing with textual data, it could be sentiment analysis, emotion detection, or any type of problem, or text generation, okay, or summarization, or even audio data like speech recognition, text to speech or speech to text. This is known as NLP. Now there are specific classes and functions in Scikit-Learn that you will be using for NLP problem. But the question is it possible to directly train an ML classifier or ML model on this data? Yes, we can, but the model will throw an error. If you directly feed this text with this corresponding target column, binary classification problem, then the model will throw an error for this string. This is text, this is string. Model will not be able to understand this text. And in NLP, when you want to convert this text into numbers or some unique IDs, that is known as text transformation or vector creation. So you have to properly convert these words or vectors into sentences into vectors. Only that ML model will be able to understand. So before discussing and implementation of the first technique, which is bag of word, by the way, we have a lot of techniques that we will see in future. Let me quickly show you the data set that we will be using for this problem. So import pandas. This is the data set. Since this is quite big data, which is 50K movies reviews, so I'm just going to get 3000. So let me run it. So as you can see, we have this data. This is input column, which is a review, and this is target column, which is sentiment, where we have two classes, positive and negative. If I just show you df sentiment, and if I just call value counts, you will be able to see we have positive. Total we have 15,000 reviews for positive, and we have 1,500 for positive and 1,492 for negative. Okay, now let me quickly do trend test split. So it's same as we have seen in previous a lot of videos. You have to go to Scikit-Learn, model selection. From model selection, you need to import trend test split. Okay, and then you have to create for set xtrend, xtest, ytrend, white test, and then you have to call trend test split by passing input feature, which is review. So df review, and target column, which is sentiment. So df sentiment, and then test size 20% will be for test, and remaining 80% data will be for training purposes. And you can also pass random stat with 42. Okay, so this is trend test split. Now if I just show xtrend, these are all the reviews in xtrend. So let's train an ML model directly with this text, and let's see if we are getting error or not. So for this problem I am going to use support vector classifier, because there are couple of models in machine learning or in scikit-learn, like support vector classifier, gradient boosting classifiers, that are specially designed for NLP problems, and they are good for textual data. So SVM, from SVM import support vector classifier. Okay, so let me create an object, support vector classifier with default parameters, and then let me train it quickly. Fit by passing xtrain and ytrain, right? And then let's do prediction. So model.predict on 20% data, which is xtest. Now let me also evaluate this model. So we need to call from matrices, we need to import like classification report and confusion matrix. Okay, and then let me calculate first classification report by passing actual data, which is y-test, and predicted data, which is y-pred. And let me also do the same for confusion matrix by passing actual and predicted. So run it. So you will be getting an error. As you can see, it is value error, that the model could not able to understand the string. As you can see, I am amazed. This is the review. So this is the problem. Now to solve this problem, we have a technique in NLP or data science that is known as text transformation. So in NLP, converting text to numbers is done using techniques like bag of words. This is the first technique that we are going to discuss and implement in this video. And another technique which is quite efficient in comparison to bag of words, that is TF-IDF, that we will be discussing in next video. We have also word embeddings. We have another embeddings in deep learning. So this is known as text transformation, when you convert text into vectors with some unique IDs or numbers, so that the ML model can understand it. Okay. Now the first technique that is used to convert text into number is bag of word. Bag of word works by converting text into fixed length vectors. As you can see, this is a fixed length vector. This is another vector. This is another vector, based on word frequency, ignoring grammar and word order. Each unique word in the corpus becomes a column, and the value is the count of that word in the sentence. Now let's understand it. Suppose that we are going to train an ML classifier on this 3 document or this 3 sentences. So we have total this data. Now the first step, you have to get all the unique words. So in NLP, first we are going to remove all the stop words like I, like all the pronunciation, I, he, she. These are all the pronunciation. These are irrelevant words, we don't need it. And all the preposition like those, from, with, we are also removing that words. And stop words, like all the verbs, preposition, pronunciation. So once you remove all that words, then you will get with love, movie, happy, sad, movie, and finally you are getting unique words. So once you create a corpus of this entire data, create a unique words data, then you will be remaining with these words: love, happy, sad, and movie. So if you are going to use bag of word, what it will do, it will create columns for all the unique words. Each word will represent a unique column, and values, where for each word we will have frequency. So as you can see, this is the first document or sentence where we have only two words, love and movie. Once you create a vector for this document, you will have 1001 because the first column where we have love, and in this document we have also love, so it will be on. There will be a counter frequency. In the same document we don't have happy, so it will be off. We don't have sad, so it will be off. But yes, we have movie, so it will be on. And if you focus on the second document or sentence, we don't have love, so it will be off. We have happy, as you can see we have happy, so it will be on. We don't have sad, so it will be off. Yes, we have movie, so it will be on. And if you focus on third, we have sad and movie, so sad and movie will be on, remaining will be off. Now these are vectors. This is the first vector, and if you force this vector to ML model will understand it easily and you will not be getting any error. I hope you get the main idea. Now there is a mathematics, how it works. We don't need to understand all those stuffs, but you must have some basic idea. Okay, so now let me run it again. Let me rerun, and let me also do trend test split. Now since we are going to use the first technique, bag of words, for bag of words from Scikit-Learn, there is a class Sklearn dot feature extraction. You have to go to feature extraction, and within feature extraction we have another class which is known as text. From text you have to import count vectorizer. This count vectorizer is basically used as a bag of word. Now you have to create an object of count vectorizer by any name, let's say vector. I can give it a name, vector or vectorizer, and then call count vectorizer. Now you can go with default parameter, but you can set its parameter. Let me go with default parameter, then we will discuss that how you can use some parameters by improving the model. And once you create an object of this feature extraction tool, then you have to apply on your review text. So basically we are going to apply on xtrend and xtext because these are our input features. So here I can say xtrend bag of word, or you can give it any name. Then let me call vectorizer, then fit transform, and pass our xtrend. And let me also do the same for test. So vectorizer, but this time you can only call transform by passing your xtest. Okay, so if I just show xtest, how it looks like, since it will be a dense array, so I have to convert it into array just to show you how it looks like. So for each sentence or document you will be getting this list. Basically this is a vector where you will have 0 and 1. If it is 1, then it's mean that the word is present. If it is 0, then it's mean that the word is not present. Okay, now we are going to train an ML model on this data. So here I can just pass, instead of xtrend I have to pass xtrend bow and xtest bow. So let me run it and we will see what we are getting for this data. So it's in running. Now whenever you are dealing in textual data, some cases you will be getting a little bit time. So as you can see, the model is giving us 76 accuracy for this data, and you can also see for negative class precision, which is 82, recall, which is 69, F1 score, which is 75. Since we are only using 3000, if you use 10,000 rows or 15,000 rows, you will be getting maybe 97 or 96. But can we improve further this accuracy? So yes, we can if we add some parameter while creating object. So the first parameter that you will be using in bag of word, that is n-gram range. Now you might have heard in NLP there is gram, bigram, trigram, 4 gram, 5 gram or n gram. So I want to use single gram and bigram. I just want to basically single words and pair of consecutive words combination for my this count vectorizer. In this way, this count vectorizer will capture more understanding the relationship between words. Okay, and another word that is max features. Now since we are going to use a real word data, we might have a lot of words, unique words, so we have to limit them. So you can normally use, if you are a bigger data, then you can set 5,000 features, but for now I am going to use 1,000 features. It will work for me. And there is another parameter which is stop words. So we have to remove stop words because these are all irrelevant words, like pronunciation, I, she, he, they, or all the preposition like from, with, below, and other irrelevant words like verb, is, am. Okay, so here if your data set in English, if this is in English, then you have to set here stop words English. Okay, if you are using French, then you have to set French. Okay, so let me run it again, and let me also run and retrain the model so that we can check if we are getting performed version. So as you can see, we achieved a little bit performance by just changing the parameter. That is the beauty of this technique, that you can do some tuning by changing just these values, and you will be getting some improved version of your model. Okay, so if you use 15,000 rows data set, you will be getting 100%, 95 or 96 accuracy. So let me quickly create a prediction system. Let's say I have another new input. The movie was good. This is, as a human being, I can say that this is a positive sentence, but let's see what the model predicts. So model, which is already trained, just pass your new input. Guess what will happen? You will get an error because this is again string. So since our model is trained or vectorized data, so before prediction we need to convert this new input data into numbers. So we have already a train vectorizer, just call it, and this time you just need to call transform, and you need to pass in list this new input text. So we just convert it and we store right here, and now you can pass this to your model. So as you can see, for this data the model predicted positive. And if I just change some words like, let me make it negative. The movie was paid total wastage of time. So as you can see, it was negative, and the model is also saying negative. For text transformation, that is known as TF-IDF. Okay, so in previous video we have already seen about bag of words, that what is bag of words and how you can transform text with bag of words into vectors. So you can do the same thing with another technique which is very efficient and you will mostly use in real world project, that is TF-IDF. So before understanding, let me quickly show you the data set. So for this project we are going to use this NLP textual data for emotion detection. This is input feature or input column where we have some text or human emotions, and this is the label for each text correspondingly. So if I just show the label, you can see we have couple of classes like joy, sadness, anger, fear, love, surprise. So basically, if you want to create a model that will detect human emotion for a given text, then you can use this type of data set. Okay, and after that we have already seen that how you can do trend test split. So as you can see, for that use trend test split, and this is our input features, target. Then we have created 4 sets accordingly: X trend, X test, Y trend, Y test. So let me run it. Now we need to convert or create vector for each document using some feature extraction or text transformation technique like bag of word or TF-IDF. So as I already mentioned that we are going to use TF-IDF. So what you have to do, you have to go to feature extraction, and from feature extraction you have to extract TF-ID vectorizer. Like previously we have seen how you can import count vectorizer. Basically, count vectorizer is used as a bag of word. Okay, then you have to create an object, but since this TF-IDF vectorizer couple of parameters like number of gram range, where you have uni, gram, bigram, as you can see, and maximum number of features where we have passed 100. This parameter is basically used to limit your vocabulary to 1000 terms only, I mean 1000 words. Stop words will be English, like we want while creating vectors, remove all stop words like verbs, preposition, pronunciation, all irrelevant words. Lowercasing will be true because we don't know, maybe there are a couple of letters in uppercase, some will be in lowercase, so you have to bring them to lowercase. So you can do with Python, but since this TF-ID vectorizer also provide lowercasing will be true. This parameter minimum df basically it means that ignore those words that appear less or fewer more than 2 documents. Okay, only filter rare terms. We will discuss this a bit later, but you can see we have created an object. Then we have applied this vectorizer by calling fit transform method on our xtrend and xtest, because these are our text or input features. So once you run, this time you will not be getting binary values, but you will getting some values. If you are getting, this is first document, okay, this is the first document vector, I mean this. So this is the first document, and once you convert it into a vector, then you will be seeing like this list, and this is known as vector or feature vector. Now if you here you can see for a term a 0, it means that word or term is not important. Okay, but if you see something like this, some higher value, then it means that term is important. Okay, after that we have imported logistic regression with classification report and confusion matrix, then created object. As you do always, whenever you import a machine learning model, then you have to create an object. Once you create an object, then you have to train by passing your xtrain and ytrain, which is actually 80% data. After that we have tested the model by calling classification report and confusion matrix by passing actual versus predicted data. So once you run this cell, as you can see, this is the complete classification report for logistic regression. For each label or emotion you can see precision, recall, F1 score. Since this is a big data, but just for tutorial purposes, I have used only 3000 rows. I think this is total 50,000 rows or 16,000, but you can use more rows, it will improve your model accuracy further. So overall this model has achieved 75 accuracy. You can see confusion matrix as well. Here the model is also doing some misclassification, but mostly it has done correct classification. Now let me quickly give you prediction system so that we can check our model, then we will discuss what is TF-IDF vectorizer and how it works. So prediction system like this. Now here new input, let's say I am very angry, and the first thing I have to convert, I have to create a vector of it. So vector input, then I have already a train vectorizer, so I can just call by calling transform method and by passing this new input. So if I just this vector input, you will see a vector. If I just call to array, as you can see, now this is a single vector. Okay, now let's train a model. So model.predictor by passing this vector. So as you can see, I'm very angry. So this is clearly mentioning that the person in this message clearly expressing anger. As you can see, anger. The model is also predicting anger. So if I just change it, let's say he is very happy to see butterfly. Let's see. As you can see, the model is predicting joy. So you can clearly see the model is performing well, but yes, we can improve to 90 to 99 if we increase the data set to 15,000 records or maybe 20,000. Now let me quickly explain you that how TF-IDF vectorizer work. So the overall idea for all these techniques, either bag of words, count vectorizer, TF-IDF, word embeddings, or even in when you will be working with deep learning, you will be seeing a term embeddings. Okay, so all these techniques are used to convert textual data into numbers, and those numbers will be basically a vector. Okay, but each technique works in a different way. As previously we have seen, bag of word works to count frequency for each word for each document, right? But TF-IDF vectorizer basically calculates score. It will give higher value to rare terms, important words, and that will be important words for all document if it has higher score. If there is a term which is common across all documents, then it will give lower value. Okay, so TF-IDF stands for term frequency inverse document frequency. It is widely used technique in NLP and information retrieval application that basically convert textual data into vectors or feature vectors that will help you to analyze and compare importance of words in document relative to entire words or data set. So there are two terms, TF, which stands for term frequency. This basically measures that how a term or word appears in a document. It could be most frequently or not most frequently. IDF is basically measure how important a word, here term means word, is by decreasing the weight of terms that appear in many documents. Let me give you an example, you will better understand. As you can see, we have this three document, basically you can call it row or sentences. The cat sat on the mat, the dog sat on the log, cats and dogs are pets. As a human being, you can easily tell me that here in first document, cat, sat and mat could be important. In second document, dog, sat and log could be important. In third document, cats, dogs and pets are important. But what if I ask, can you tell me, is this word cat can be important or more higher values across all document? So if you figure out, in first document we have cat, in second document we don't have cat, in third document we have cats. So we can say that cat could be important for this data set based on its frequency. So first we have to calculate term frequency for each document. Now for single document you have to calculate term frequency. Formula could be like number of words that appear in that single document. Like for each word, for first word, if you want to calculate this document or TF-IDF, then you have to divide this word by all words of this document. Okay, total number of words in that document. So here if we are going to calculate TF-IDF for cat, so cat, which is only one times in this document, divide by all words 1 2 3 4 5 6. So 1 divided by 6, and it will give you the importance of that word for that document by just using this TF-IDF. After that, and you have to do this for all words, then for cat, then for set, then for on, the, met, and the same thing for all other documents. Inverse document is basically reduce the weight of word that occur in many documents. Okay, and the formula is n divided by 1 plus df of that word. So if I just show you right here the example, as you can see we have this all words. Once you collect all the unique words from this data, you will be seeing like this. Then if you want to calculate for first document TF-IDF, then further you will be getting 0 because this is not important. For cat you will be getting this number, for set you will be getting this number, for on you are getting this number, mat, for dog you are not getting anything because we don't have dog in this document. As you can see in this document we don't have dog, and also for log. But you will be seeing for document 2 TF-IDF, as you can see, for set, on, and for dog and log you are getting higher values, and for document 3. So the main idea behind TF-IDF shows that how much a word important is for each document and across all documents. Okay, and basically we have started working with textual data like natural language processing. And we have learned 2 to 3 classes that are basically used for converting textual data into numerical representation. Because as we have already discussed that machine learning model, if you feed a textual data to an ML model, then ML model will not be able to understand that textual data directly. You have to specifically convert the text into some numerical representation or vectors. And for that we have seen count vectorizer and TF-ID vectorizer. So in this video we'll be working with a hashing vectorizer, which is basically used to convert textual data into numerical representation or vectors, same like count vectorizer and TF-ID vectorizer. Now before understanding hashing vectorizer, let me quickly give you an overview of count vectorizer and TF-ID vectorizer. So as we have seen and discussed, that count vectorizer is a technique that basically converts textual data into numerical representation, where you'll be getting a matrix with mostly 0 and 1, where 1 represent occurrence of that word and 0 will represent no occurrence of that word. Okay, and TF-ID vectorizer basically convert textual data into numerical representation, but based on some score. If there is higher score, it's mean that that word is important for that data set. If you are getting lower score or either 0, then it's mean that that word is common word and not important for that data. So overall the main idea is to convert textual data into numerical representation, that is known as feature extraction in NLP or textual data. Now before discussing and understanding hashing vectorizer, let me quickly give you the coding part, as for other 2 techniques we have already seen. So what you have to do, you have to go to Scikit-Learn, and in the same way as we imported count vectorizer and TF-ID vectorizer from feature extraction.txt, you have to import a hashing vectorizer. Now since in this video I am going to use this dummy data where I have only 2 documents, I am happy and dog is happy. Okay, so you can use only these 2 documents just to understand hashing vectorizer technique. Now before feeding this data to your ML model, you need to create a vector of this data where you will have 0 and 1 or some numerical IDs or numerical representation, and the same thing goes for the second document. So either you can use count vectorizer, IDF vectorizer, but the question is which one and when to use which one. So before answering this question, let me give you that how you can use hashing vectorizer. So you have to call hashing vectorizer. Now hashing vectorizer has couple of parameters, hyperparameters like number of features, norm, alternative sign. So we will understand this, but yeah, you can see we have created an object. Now you have to apply this vectorizer on your data set, which is basically docs, by calling fit transform method. Now finally we have this X. So I have created here a data set. Now this is very important if you really want to understand hashing vectorizer. This is the first document where we have 10 columns, but basically if you check, we have only 3 words. So there must be only 3 columns, or if you get all the unique words, then there might be 5 columns. 3 and 2 will be equal to 5. But why we have 10? Because we have set number of features 10. We will understand that a bit later, but yeah, you can see this is document 1, this is document 2 vector, where you will be getting 0 and 1. Now from 0 to 9 means you have set number of features as a hyperparameter is 10. If you set 100, let's say 20, you will be getting 20 features, but for now let me set 10. And here 1 represent that word occurrences, as you can see. Now let's understand what does it mean and how hashing vectorizer works. But before that, let me quickly give you an overview. Once you apply hashing vectorizer, you will be getting such type of data set. Okay, this feature, basically the hyperparameter that you have set, this is the index of that word. Okay, and this 0 and 1 will be the vector which represents the occurrence of that word. Okay, now let's understand hashing vectorizer. Now before understanding, once you watch this video completely, then I recommend you to watch this video as well. I have placed the link right here Once you open the notebook, you'll be redirected by clicking on this link. This is quite interesting video. You'll understand in a more better way hashing vectorizer. So I have copied this screenshot from that video, but let me quickly give you the general overview of hashing vectorizer. Okay, so since we have these two documents, I am happy, dog is happy. So once you apply hashing vectorizer, you will be getting this matrix where you have two vectors. This is first vector with 10 features, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, total 10. And you will be getting the same for the second matrix, because you have set while applying hashing vectorizer the hyperparameter number of feature 10s. Now let's understand why we have one here, and why we have one here, why we have one here, why we have two here, and why we have one here. Why we are not getting one right here? Because we have three words, so directly we must have one right here. After that we might have zeros. Let's understand. So hashing vectorizer internally used, if I just give you the general definition, hashing vectorizer is a textual text feature extraction tool in Scikit-Learn that basically convert collection of textual data into a matrix of token occurrences using hashing tree. Unlike other techniques like count vectorizer and TF-IDF vectorizer, it doesn't store vocabulary of dictionary. It basically make it more efficient, memory efficient and suitable for large scale of textual dataset. So as in this video initial part, I have asked that when and where, which techniques to use. So if you are dealing with large data set, if you have data set with 20,000 rows or in million, then converting the text into numbers, you need to use hashing vectorizer. It is recommended instead of using TF-ID vectorizer or count vectorizer. But if you want to extract more important words, then use TF-ID vectorizer. But if you are dealing with a small data which is not important, then you can go with count vectorizer. So let's understand our problem, like hashing vectorizer. So hashing vectorizer will get the first word, which is I, and it will calculate hash value. So once internally it will calculate hash value, it will give some random numbers. Now you don't need to worry about this random number. This is basically a hash value for first word or token, which is I. Then you will get this value, or you can say hashing vectorizer will get this value, and it will take mod. Mod is basically the number of feature that you have set. If you have set 20, then it will take this hashing value mod with 20. But since we have 10, so for I we have get this hash value, which is 168 up to this, and you will get mod with 10 because number of feature is 10. So you will be get the remainder. So whatever the remainder, that is the hashing index for that word. So here we have get 6. It's mean that on index 6 you have to put, which represent I. So index 0, here feature 0 is basically index 0, index 1, index 2, 3, so on. So if I just calculate this like index 0, 1, 2, 3, 4, 5, which is 6 basically, because started from 0 will equal to 6. So on index 6 or column 6 we will have 1 which represent I. Now let's take M. So if you get hash value for M, it will looks like this, which is basically a random number. Okay. After that you have to take, or you can say hashing vectorizer will get or calculate mod, which is 10. So once you get mod of this value, you will get at. It's mean that on index at your M word will be located or present. So 0, 1, 2, 3, 4, 5, 6, 7, which is basically at. So on index 7 we have 1, which means on index 8 or in our column 8 we will have 1 which represent M. The advantage is, if another document you have also M, it will directly put that in the same index at. This is the beauty of hashing vectorizer. But sometimes what will happen, different words will be collided in the same index. As you can see, for happy we get 1, so 0, 1 on one index we have happy. Now let's say for second document, so we have taken dog, and let's say after calculating mod with that random value of hashing value, we are getting 3. So 0, 1, 2, 3. On index 3 we have 1 which represent dog. Now we don't need to do again for happy, but let's say for happy, for is. So once you get hash value for is, and once you get mod, let's say we have 1. But now you can see we have same reminder value for 1 and happy from first document, which was on index 1. And on second document we have another word which is totally different word from happy, that is, but it is also located on the same index. So what will happen? It will collide. So this is the basic intuition or understanding behind hashing vectorizer. Okay, if you want, once you open, you can understand everything because I have right here. Now you can get some sentiment analysis data that we have used in previous few videos, and you can apply hashing vectorizer, and then you can apply TF-ID vectorizer, and you can see which one is giving you best results, and then accordingly you can go with that one. Now here hashing vectorizer has 3 features. Number of features, as we have said 10. It's mean the number of columns or word index that you are going to use for your hashing vectorizer transformation. Whatever the output matrix you have, if you choose a smaller number, it will increase the chance of a hash collision where different tokens map to the same feature index. There is another parameter that is norm. There we have set none. Basically internally it use some normalization. You might have heard in machine learning like L1, L2, L3. So by default it uses L2. So if you set to none, it will disable it. Okay, because I don't need, since I'm dealing with dummy data, so I don't need to use that one. Alternate sign basically ensures that all hashed values are non-negative. After getting this matrix, it will give all positive values instead of negative values. So by default it is true, so you can make it false. So yeah, that was the basic introduction and implementation of hashing vectorizer, but I recommend you to watch this video after watching my. And we have also started NLP with Scikit-Learn. Okay, so from now on we are going to also continue our Scikit-Learn playlist, especially textual data, I mean NLP, but this time we will be working with topic modeling classes. That is also come into the category of unsupervised learning problem. Now before understanding what is topic modeling, what is unsupervised learning, so in the next 3 videos, including this one, we are going to continue our discussion and implementation with these 3 classes that are used for creating topics or extracting topics from textual or documents. Okay, so the first one is LDA, which is also known as latent Dirichlet allocation. The second one is NMF, which is also known as non-negative matrix factorization, and the third one is truncated SVD. So in this video we will focus on LDA. Okay, now before understanding LDA, you need to understand what is topic modeling. So if you have a textual data, a lot of textual data, for example, if I give you a book and I ask you, tell me about this book, what has been written in this book, so you have to read all that book, and after completing or finishing that book you have to tell me the conclusion. But what if you have a machine learning algorithm and by passing that book and it automatically tell you the main theme or main topic about that book, that is known as topic modeling. So what you have to do, if you have a lot of text and you want to directly summarize it by understanding its main theme or topic, then you can use in machine learning the concept that is known as topic modeling. So yeah, that is topic modeling. Now since machine learning has mainly 4 types, supervised learning, unsupervised learning, reinforcement learning, and semi-supervised learning. Okay, so in this playlist we have already seen a lot of projects and implementation for supervised learning problem, including classification and regression. So since I was supposed to continue unsupervised learning a little bit later in this playlist, but since we are dealing with NLP and topic modeling is a topic, or you can say a concept of NLP, and these 3 classes also belong to textual data or NLP, but this comes into the category of unsupervised learning. So unsupervised learning is a problem when you have a data that is unlabeled, where you have only input feature without any corresponding target column. Okay, that is known as unsupervised learning problem. Now let's understand LDA. Now your main focus should be on LDA and LDA implementation with Scikit-Learn. Okay, so as you can see, we have these documents. You can consider them a lot of text, and this is a machine learning model. So once you pause this text, this machine learning model will classify or put that text into different groups. That groups will be known as topics, and each group will have similar words, or you can say similar document or similar concept, and based on all those concepts you will easily understand this entire document. So you don't need to read all this text or book. You just read this topic or main theme and you will understand the main concept or main theme of the book. Okay, this is known as LDM. So but the question is, why we need to use LDA for such textual data? So basically the problem could be the same. If you have a large collection of text and you want to know what people are talking about by just reading few lines, or you can say summarize, then LDA could be helpful. And if you want to group similar documents, and this concept could be known as a recommendation system in machine learning, then you can also use LDM. You can also create, if you have a lot of text and you want to make that data label, then you can create label based on similarity. Okay, and if you also want to summarize textual data like tweets, reviews, emails or reports without reading them all, then LDA could be helpful. So our problem statement could be that we have a customer reviews and we want to get or extract main topics. So since I am going to use this dummy data, but you can also use this Kaggle wala data. Okay, so what you have to do, you have to go to Scikit-Learn, and from Scikit-Learn decomposition, you have to import latent derelict allocation, which is known as LDN, that is basically used for extracting topic or main theme for a lot of textual data. Okay, now since we need to convert that text into a numbers, that is known as text transformation or vectorization. So what you have to do, from feature extraction.text, you have to import count vectorizer, or either you can use a hashing vectorizer or TF-ID vectorizer that we have already discussed in the previous few videos. Okay, yeah, so we are going to use this data. So as you can see, this is quite simple and few data where we have, this is the first document, or you can consider it a sentence. 2, 3, 4, 5, 6. So total we have 6 documents related to politics, government, health and medical. Okay, now first you need to convert each document into a vector by calling this count vectorizer. So fit transform and then pass your documents, which is basically your data set. Okay, so if I just run it and show you how it looks like, x2 array. So as you can see, for each document you will get a list that is known as vectorization, and each list will have two values, 0 and 1. 0 represent the word is not present, 1 is represent the word is present. Okay, and this is the second document, this is the third document, this is the fourth, fifth and sixth. Now since we have successfully converted our text into numbers, now we can use our machine learning algorithm, which is basically LDA, right? So you need to create an object of LDA. Now here LDA couple of parameters like number of components. Basically here you have to select the topic that you want to extract from the text and random state, and you can set any value. So now this is an object. Now you can call fit and pass your data. So once you run, it will automatically extract topics, and for each word it will have some score. So if I just go to LDA, which is the model, and call this function that is known as components, then you will get all the words, and for each word you will get some score. Now we are going to extract top 5 words for each topic. Okay, and that will be the theme of that entire text, or you can say topic or main words or theme or summary. Okay, so what you have to do, first we need to get all the words, because as an output we need to show that words instead of that specific value. So then we have run this loop with enumerate by calling all these components one by one. We are getting each word score, and here we are printing the topic index, and then we are getting that score word from these words by calling this line of code. Okay, so once you run it, you will get for topic 1 we have this words: policy, new, health, government, past. And topic 2 we have opened, market, sold, stocks, strong. So you can easily understand second topic is mainly representing market. If I just focus on these words, strong word is mostly used in market, stocks is mostly used in market, sold is also used in market if you have higher values, open is also used in market, and market is as it is. So topic 2 is specifically represents some kind of market. So if you can consider, then you can say that yes, all these book could be related to market, all those things. Okay, and topic 1 is mostly focused on government and health. Okay, so now you can see if you have a quite big data and you run this code, you will get the main theme right here. Okay, and the implementation could be changed, could be a little bit different, I mean the output, otherwise the implementation will be same. Okay, NMF, which stands for non-negative matrix factorization. Okay, so before starting, let me quickly give you an overview that what is topic modeling and why we do topic modeling. So topic modeling is basically a technique in natural language processing for textual data. So you can understand topic modeling with the help of an example. Let's say you have a lot of textual data and you want to understand what people are talking about in that text in few lines of text. Then topic modeling would be helpful because topic modeling will extract main theme or main words. So this is the second class, which is known as NMF, non-negative matrix factorization. That is a technique that basically helps to find out hidden themes or topics in a collection of text like news articles, tweets, or research papers. It works by breaking down the content into parts that make sense and are additive. In simple terms, it basically finds patterns where certain words often appear together, that basically forming a topic. Now the main question is, why do we need NMF? We use NMF when we want to understand what topics are being discussed across many documents without reading them all. You can consider it like if you had a big pile of books or emails. So NMF will help you automatically organize all that documents into different categories. So let's say if you have a lot of documents related to health, finance, and technology, and once you apply NMF, it will easily categorize them, all the documents that are related to health, and all the documents that are related to finance, and all the documents that are related to technology based on words and their relationship. Okay, so when should we use NMF? You can consider it like if you have a lot of unstructured textual data like customer reviews, articles, and transcripts, and you want what are people being discussed or talking about, then topic modeling will help you. Also NMF. And if you want to automatically discover the main themes or categories, then again LDA or NMF will help you. So we are going to use this simple data set where we have 10 documents. Okay, now we want what people are talking about in all these documents by seeing couple of main topics or theme. So the first thing, we need to create vectors for each document. So as we have seen, we have a lot of techniques like vectorization. So you have to go to feature extraction.txt and you have to import TF-IDF vectorizer. So this will easily create vectors for each document by giving higher value to most important words to the entire document. Okay, so then what you do, basically you create an object of TF vectorizer. So here you can pass couple of parameters, but for now let's say just we are going to use stoppers. And after that you apply this vectorizer on your document by calling fit transform method. So these are basically documents. So let me give it a name X. So if I just show you how it looks like, you can call this. So as you can see, this is the first document where you will have columns for each word, and if you get higher value, it's mean that word is important for this document. Okay, as you can see, this is another document. So now we have properly created for each document a vector containing some values. So now we can apply NMF. So here let me create an object of NMF. So NMF. Now NMF takes two parameters like number of components, how many topics you want to get. So for now, let's say we are going to get or extract 3 topics, and random starter, it could be anything like 42. And then you apply this NMF by calling fit method, or even you can call fit transform method on your X, which is the transformed matrix. Okay, and let me store this result so that we can explore it. Now if I just go to NMF and call component, so you will see this scores. Now this matrix is basically a matrix of numbers, and it shows how important each word is to each topic. Like each row is one topic. Here you can see, if I just show you, this is the first row. So basically it is the first topic. We have 3 topics, so we will have 3 rows. As you can see, this is the 3rd row, and this is the 2nd one. Okay, and this is the 1st one. And each column, as you can see, this is the column. This is 1st column. This is 2nd column. Each column is one word from this entire data set. Okay, and the number, as you can see, this score, the number at each position basically tells us how strongly that word contributes to each topic. Okay, I hope you get the main idea. Now since we have scores, so we need to properly display the words for each score. So what we can do, if I just get features by calling vectorizer dot, here we have a function get feature names out. So you will get all features names. As you can see, these are all the features. And now let me run a loop that will get index and score in enumerate by calling our model, which is NMF. What was the name basically? NMF, yeah. NMF dot component. So if I just print IDX and score, you will see for each index you will get that entire list of words. Now we can use these features and properly display top 5 words for each topic. So I have this code basically where I have explicitly extracted all the feature names, basically word name, and I'm interested to get for each topic 5 words. So we have 3 topics, and for each topic we will have 5 words. Then this is the same loop. Either you can call directly component, but since I have already created here an object, so we have already, just let me give it a name like this H. Okay, or you can directly call it NMF dot component. It will work in the same way. Then we have display the topic, and then we have get top features, meaning top 5 words for each topic using this logic. So if I just run it, now as you can see, for topic 1 we have this word. So here people are mostly talking about dogs and human relationship. Here pets are dogs, basically man, friend. So basically they're talking about dogs and human relationship. In topic 2, people are mostly talking about health and nutrition based on these words, or you can say based on this summary. And in topic 3, people are mostly talking about AI. So conclusion or the output can be considered from this document that people are mostly talking about humans and dogs relationship, health and nutrition, and AI. So you can see now, you can consider it like if you have a lot of text, then you can easily, based on your output, by applying topic modeling model, you can easily consider what are people talking about. Okay. Truncated is SVD, which is also known as LSM. So this is the last video of topic modeling, especially for textual data. So as we have already discussed that all topic modeling models are used to extract main theme or summary from a large amount of textual data, so that you can understand what people are talking and that document or data. Okay. So truncated SVD do the same. So what you have to do, you have to import pandas, and from feature extraction datax you need to import TF-ID vectorizer, and from decomposition you have to import truncated SVD, same like LDA. Okay. So again we are going to use this dummy data where we have 3, 3, 3, 9, 1, 10 documents. Okay. Now we don't know what this text about and what people are talking about. So if you want to understand this, then you have to apply topic modeling. But before that, you have to create a vector for each document, because ML model will only understand numbers instead of this text. So you can use a lot of technique, but since we have used TF-ID vectorizer, then we have applied on document TF-ID vectorizer, and finally we have this vector matrix for all 10 documents. Okay. Then we have created object by the name of SVD for truncated SVD with number of components 3, because we are interested to get 3 components or 3 topics from this entire document or data. Then we have apply SVD on our transformed data, and this is the result. Now since we have seen all these things in previous 2 videos, now if you want to display top words for each component or topic, you need to use this code. So first we get all the terms, the actual words that we have transformed with vectorizer. Then we have run a loop by getting component or score and its index using this SVD that components. So if you have seen the previous 2 video, then you might be familiar with. And finally we are displaying top 10 words, or let me make it 5. Okay, top 5 words for each topic. So this is the first component or topic where we have top 5 words with score: learning, machine, deep, amazing, subfield. So here people are mostly talking about machine learning and deep learning. We can consider it, or we can conclude it. In second component, people are mostly talking about models and natural language processing. And in third, again, people are talking about technology, AI and future. So overall, we can say that whatever the text is, it could be millions or trillions. People are talking about technology, AI, ML models and deep learning models. So that is the beauty of topic modeling, and all the classes that you are using for topic model like LDA, SVD and truncated SVD. Okay. Recommendation system in machine learning using Scikit-Learn. Now before discussing a recommendation system, let me quickly give you an overview. If I just go to my Chrome browser and let me open a new tab. Now this is a search engine provided by Google, and I can search anything right here. Let's say I'm going to search Elon Musk. So the moment I click enter, Google will recommend or suggest me all blogs, links, images, videos related to my search query, which is Elon Musk. So as you can see, we are getting all the images related to Elon Musk, and here we are also getting Elon Musk Wikipedia page, Elon Musk X page, Elon Musk Forbes, Elon Musk Tesla. So the main idea behind this search engine, what happened basically? So Google get or take this query that you have typed and compare with Google database, and based on some similarity score, Google fetched all the links or all the queries or images that are related or more similar to your query, which are basically Elon Musk. This is known as recommendation system. Okay, so recommendation system basically suggests you items, products based on your search query or your preferences. So my preferences was to search Elon Musk, and Google suggests me all these things. If I just go to Amazon platform, this is amazon.com, and this is the search engine of Amazon platform. Now here I am interested to search, like, let's say sunglasses. So the moment I enter, Amazon recommendation system will suggest me different categories of sunglasses, but these are all my preferences because I was interested to search for sunglasses, and this is known as recommendation system. So recommendation system is a technique in machine learning or Scikit-Learn that suggests item to user based on features of items they have previously liked. This is another type of recommendation that we will see in next video. But basically recommendation system compares item attributes like item genre, keywords, description, title, and based on user query, it will fetch you or it will recommend you more similar items. This is known as content-based recommendation system that we are going to implement in this video. Okay. Now for content-based recommendation system or search engine-based recommendation system, Scikit-Learn provides a class which is known as cosine similarity. So this is the formula. If you learn this formula, then things will become very easy for you. So basically, if we just take two vector or two product A and B, let's say A is orange, B is apple. So what you do, basically you take product of vector A, which is orange, with vector B, which is apple, and then you divide by taking magnitude of vector A, which is orange, and multiply, but before multiplication you also take magnitude of B vector, which is apple. So once you calculate this, you will get some theta score, and that score will be your similarity. If it is higher, it's mean orange and apple, or you can say vector A and B are more similar based on that score, if it is higher. But if it is lower, then we can say that this two vector or product or items are dissimilar. Okay, this is known as recommendation system or content-based recommendation system, where you use cosine similarity. So cosine similarity basically create a vector for one product or item or document, and then compare with all remaining or other products. So for that problem, I am going to use e-commerce product dataset. So let me quickly import pandas SPD, then let me load the dataset, which is a CSV by the name of lecture 32. Let me check. Lecture 32 clean data.csv. Clean data.csv. Let me run it. Basically, let me rerun. If I just show the DF, this is the data set where for each product we have user ID, that product ID, ratings, review count, category. It's mean that from which category this product belongs, its brand, its title or name, its image URL that you are actually displaying on your platform, and its description. And this is the column that I have created from category, brand, title, and description. So you will get this clean data because this is this column is very important. So as we have mentioned, that content-based recommendation is based on item features like its category, brand, name, description. So what I've done, I've just created a new column by the name of tags by getting from category all the category of that product, its brand name and description. And now this tags contain for each product, I mean for product this, for product, sorry, for product 2, we have properly tags, you can say keywords, and we will create a vector. That vector will help us to calculate cosine similarity with other product vectors. Now in this data for each product we have tags where we have important keywords about that product. Okay, so let me quickly add this code. So now if I just show you, now we have this data where we have user ID, product ID, rating, category, brand name, image URL and tags. But since we have already created tags, so we can work with tags. So first thing first is always, this is NLP project and textual data. So we have to create a vector. Now for creating vector, as we have discussed in this playlist a lot of times, like many times, so you can use count vectorizer, TF-IDF vectorizer. So we will use TF-ID vectorizer. So from Scikit-Learn .feature extraction .text, you need to import either count vectorizer or TF-ID vectorizer. So I'm going to use TF-ID vectorizer. And you need to go to Scikit-Learn matrices, and from matrices.pairwise, you need to import cosine similarity class, and that is the class that is used to calculate similarity between all these vectors or documents. But in our case we have products, so you can give it any name. Now before calculating cosine similarity, if I just go and show you the shape, so total we have 4090 documents, or you can say products. So we have to create 4090 vectors, and then we will call cosine similarity to calculate for each product its score with all the other products or documents. So let me create an object by the name of vectorizer, and then let me call TF-ID vectorizer. Now since it's a couple of parameters like stop words, let me set English, max df, let me set 80%, and mean df, since we discussed all these things in previous videos, so 0.5. okay. So as you can see, we created an object for TF-ID vectorizer with all these parameters. Then we have applied this vectorizer on our tag columns, because this is the column in which we are interested. So now if I just show you TF-ID matrix.toArray by running it, as you can see, for each tag or for each document you will get a list of zeros and ones, okay, or with some scores, but I don't want to show it. Now this is very important. Now by calculating cosine similarity, what we are going to do, we are taking first item, product or vector, and we are going to calculate score with all the other products, which will be I think 4089, okay. And then second vector will be calculated with this and all the others, and third will be calculated with all the other vectors, and fourth will be calculated with all the other vectors. This is known as cosine similarity calculation. So let me create here an object by the name of cosine similarity. Then let's call cosine similarity class, and there you have to pass both TF-IDF matrix and again TF-IDF matrix. So since it will return 2D, but I'm interested in single D array, so here you can call flatten method. So now if I just show cosine similarity, so it's in execution. As you can see, this is the cosine similarity score of vector 1, which is basically this document 1 with itself, which is 100%, and this is the cosine similarity score of vector 1 with second vector. So it's mean cosine similarity of vector 1 with this one, and this is the another cosine similarity score for vector 1. It's mean that vector 1 cosine similarity with vector 2, then vector 3, then vector 4, and so on. Okay, and you will get a lot of similarity of each vector with each one. And now we have this cosine similarity. We can use this one for recommendation or fetching more similar item for the new query. So here I can create a function by the name of, or before that, yeah, let me create a function by the name of content based recommendation system. It will take new query or new title or whatever you want to give it a name, title, and I just want to create a default parameter top n, that will be 10. So once we get the query, we will show top 10 recommendation because we have a lot of items, so we will just show top 10 most similar items. Now first thing first, we need to lowercase this new title. So new title will be equal to new title dot lower, and now we have to create a vector, then only we will be able to calculate cosine similarity. So vectorized title, then since we have already a trend vectorizer, so we can call vectorizer dot this time just transform method, and here we can pass new title. Since for new title we get this vectorizer format, so now we can calculate cosine similarity for this new title vectorized with all the 4090 vectorization. Okay, so here we can call cosine similarity similarity class, basically similarity like this, and we can pass this vectorized. Why it's not suggesting me? Let me copy this, Control C, and we can pass our entire this matrix transformed. So let me paste it right here. Now since it will return 2D, so I want single D, and this will be my similarity course. Okay, so if I just call these functions, if I just return similarity scores by running, and let me pass here by calling this function, let me pass here a product by the name of nil polish. So there is an error, cosine similarity. I think we need to call cosine similarity. Yeah, now let me rerun. So as you can see, we are getting all the scores, but I'm interested in top 10. So if I just call this top 10, so these are the top 10 products for this new product. Now here you can basically do calculation in different way. So let me get indexes for top 10 higher similarity scores. So what you can do, I can basically call this similarity scores, because all my similarity scores for this new products have been stored in this variable, and here I can call argument sort method, and I can do negative indexing by saying get all from negative side and only top 10, and here I can pass top n. So this will be my indices for top 10 most similar items. I can say indices. And now with the help of this indices, I can properly fetch a data frame. So recommendations, and here I can call my df, which is the entire database, and I can call location. Now here I can pass this indices, and I am going to fetch only name of the product, ratings. I think if I just check the column names, name rating, it should be uppercase. Name, let's say brand, and let's say category. Let me run it. By the way, now this time I don't need to return similarity score, I have to return recommendation. Okay, I think I have to pass it in a list. Okay, my bad. I don't need to pass it inside, I have to pass it right here, because we are fetching most top similar score based on its argument, and once we get the indices of top 10 products, then with the help of this top 10 indices we are fetching these details. So let me run it now. Let's see, hopefully it should work. As you can see, these are the top most similar items. So let me make things clear for you. So the code is quite simple. Let me run it now. Let me explain you. So this is the function that are basically in real time getting new user input. First we are lowercasing that title, then we are creating vector by calling this vectorizer, and then we are calculating cosine similarity of this new title with all the vectors that we have stored in TF-IDF matrix. Once we get all the similarity scores, then we are fetching top most similar item based on its scores by using this code. So here we are getting top indices, and with the help of top indices from database we are getting name, rating, brand and image URL, and here we are displaying once we get the new item. So here you can see we have passed nail polish. So here you can clearly see nail color polish, lichet, nobility, perfect match nail. So here you can clearly see we are getting exact recommendation. We are all getting related to nail products. Let me change from nail polish to razor, let's say haircut. So here we are getting replacement heads for this is hair cutter. If we add like hair cutter, you will get more accurate result. Hair chalk and one blade hybrid electric trimming. So again you can clearly see we are fetching exact recommendation. So again we are going to use a recommendation system concept that is known as collaborative filtering. So basically you have to apply 3 steps. First you need to create user item matrix from your dataset, then you have to calculate distance, and then you have to find similar items rated by similar users. So we are going to use the same dataset as we have used in previous video, this data which is basically e-commerce product data set. Now for collaborative filtering you must have 3 columns in your data set: user ID, product ID and the rating. So here rating represent those values or those ratings that are given by a user to a product. Okay, so let's first create user item matrix. So but before, if I just go to rating wala column, you will be able to see these values. As you can see, we have almost if I just call unique, so we have these ratings. Okay, it's I think between 0 and somehow 9, but here you can see we have 0 rating as well, so we can drop 0 ratings, we don't need it. So I can say that I need just this data by filtering. If rating not equal to 0, or let's say greater than 0, then filter those data. So now I will have proper ratings. So if I just show you data, as you can see now in rating column we have proper rating for each users. Now let's create user item matrix that will be the main thing that you will be using for collaborative filtering. So let me create a variable, or if okay, there are a couple of techniques you can use, but I recommend always use pivot table. This pivot table can help you create user item matrix. So here you have to pass index, and index always be user ID, and you have to pass columns, and that will be the product or item ID, and another value that is rating, and it must be a rating column. Okay, so if I run it, I think it should be ratings. Okay, my bad, it must be values. Okay, so now you will get a matrix. So it's taking time, I don't know why, but let's see. One thing more, it must be product ID. As you can see, we have this column, product ID. So let me give it a name, user item matrix, and let me run it. Again we have an error. Product ID, prod ID, so it should be prod ID. So now we have this user item matrix. So if I just show you, okay, now while calculating this matrix you will get NaN values. So what you can do, you can explicitly fill that NaN value with 0. Now if you adjust the matrix, as you can see, so here you will get a data frame where on index side you will have users. This is user, this is another user, this is another user, this is another user, and on column you will be getting the products. So here user, which is 0, this is the vector, or you can say row for user 0, and for this product user 0 give 4.5 ratings. For this product user 0 has not given any rating, not given, but user 0 for product 3 also given 4 rating. So this is the matrix. Now what we can do, we can calculate for each user similarity with all the other users, so that we can find out similar user for this user, and the same thing for other user as well. So what we can do, either you can use cosine similarity, but I recommend you to use KNN model. So let me quickly import, but before that, since this is a data frame, so we can create tens matrix. Okay, so from scipy.sparse you can import CSR matrix. Now this is the class that can convert a data frame into sparse matrix. So if I just show the new matrix, which is sparse matrix, you will get a proper array where each vector represent a user matrix with ratings or not ratings given to a particular product. Now let's calculate cosine similarity for each user with all the remaining user using KNN model. Okay, so from Scikit-Learn dot neighbors you can import nearest neighbors class. So this is the class provided by KNN family that is basically used for recommendation system or finding nearest neighbors or similar items or users. Okay, and then you can create an object like KNN model, or you can give any name, and then you can call nearest neighbors. Now here you have to pass couple of parameters like matrix, which matrix you want to use. I am going to use cosine similarity, and which internally it supports couple of algorithm, but we are going to use brute. Okay, so this is the code. Let me paste it right here. Yeah, so here while using nearest neighbors algorithm, we pass matrix cosine. So whenever you are using cosine, you must have to pass this algorithm, which is brute. Basically it is used to calculate similarity pairwise, especially when you are dealing with sparse matrix. Okay, so let me import it again from Scikit-Learn neighbors, import with nearest neighbor. Okay, so as you can see, now we have trained this model. Now let's quickly find out similar user for new dummy user. So I am going to paste this code right here, so you will be able to understand what is going on. So I have a new user, this 0 you can replace with actual one, but for now I'm going to find similar user from my data set for this new user. Then I have called model KNN neighbors class. Then I have passed my user item matrix, and on its location I have passed my random user. So what will happen if I just run this, and if I just call user item matrix, on this location I am going to find out this new user which is random user, and I want all similar items, and I would like to get its all values since it will be 1D, but I'm interested in 2D, so I can reshape to 1, -1. Okay, so if I just run it, as you can see we are getting all the users, but I will use this based on model. So model.knn, and then I can call neighbors like this. So first I have passed my this entire similarity or filtering out, you can say, and I just want to get top 5 or top 10, so I can use, there is a parameter provided by this k neighbors which is known as neighbor. So for now I am interested in 5. So these are the score or distances for top 5 users. So you can get distance and instances. Okay, so this line means exactly like this one. Now I can properly print by using this code. So this is quite simple, you can explore, but let me run. As you can see, these are the distances for users. As you can see, 65, 64, 65, 65, 67, and these are the users. So for current user we are getting these users that are more similar based on these distances. Now on this distance and indices, you can fetch those user records from your data set, and you can properly create a real-time recommendation system that we have seen in previous video for content-based recommendation. So from this video onward we are going to start pure unsupervised learning. As you might be familiar that machine learning has 4 types, like supervised learning where we have regression and classification. Second type is unsupervised learning, semi-supervised learning, and reinforcement learning. So we have done a lot of things for supervised learning like regression and classification, but yes, from this video onward we are going to start unsupervised learning problem. So before discussing all these things, what we are going to learn in this video, we will see that what is unsupervised learning and what is clustering. Then we will see types of clustering. Then we will start our discussion, especially in this video, with the first type of clustering, which is partitioning clustering, where you use the first algorithms like k-means clustering. Then we will define our problem statement, and then we will implement code line by line. Okay, so what is unsupervised learning? So unsupervised learning is a type of machine learning that used unlabeled data. Unlabeled data is a type of data set where you will have only input features without predefined labels or ground truth or target column. So you will not have any target column. And using some clustering or unsupervised learning algorithm, you have to create dynamically your target column by defining clusters and groups based on similarity. So clustering is a technique in machine learning that groups similar data points together based on their features without using labeled data set. And if you really want to understand deeply what is clustering and types of clustering, then I recommend to watch this video. But let me give you an example. Let's say we have given this data set, fruits data set, where we have raw data like orange, strawberries, and grapes. Okay. Now our task is to create label or target column with 3 cluster or 3 groups or 3 labels or 3 classes. Based on similarity, Okay, one thing more, here each single fruit is known as data point. So based on data point similarity, you have to put all similar data points into similar cluster. So after applying clustering algorithm based on similarity of their input features, we have created a cluster by the name of orange fruits, where we have stored all the orange. Okay, because orange are similar. And then we have created another cluster by the name of strawberry cluster, where we have added all strawberries data points based on their similarity, like color, shape, height, width, etc. Okay, and then the same thing we have done for grapes. This is known as clustering, where you will get some unlabeled data only with input features, and based on their similarity or input features, you have to create target column. Now we have this target column where we have 3 clusters or 3 classes. Okay, types of clustering. So there are a couple of types of clustering. The first one is partitioning methods or partitioning cluster, that provides you 2 types of algorithm like k-means and k-methods. So in this video we will focus on this technique, and in second video we will focus on second type of clustering, which is hierarchical clustering or hierarchical methods. And it provides 2 types of algorithm, like agglomerative clustering or divisive clustering. Okay, third type of clustering is known as density based clustering, dbScan and optics. So these 2 algorithms. By the way, one thing more, all these algorithms are used for unsupervised learning problem. Basically they used to create or put similar data point into similar cluster, but they have different techniques. Okay, fourth type is model based methods or model based clustering, and it use GMM algorithm or Gaussian mixture models. Fifth type is grid based methods with sting algorithm, and then fuzzy clustering with fuzzy Siemens algorithms, graph based clustering with spectral clustering. So as a data scientist, especially with deep knowledge in unsupervised learning, if you learn all these algorithms, then that is enough. Okay, so I think before applying code, let me quickly give you an overview of the first algorithm, which is partitioning clustering or partitioning methods. So this is quite simple, and this is the first type of clustering, and for that you basically use k-means algorithm. Okay, this basically works if you get some data or raw data, it will put all similar data points into similar cluster based on their similarity, and all dissimilar cluster into dissimilar cluster. That's the simple logic for the first type of clustering, that is partitioning. It basically divide data into groups or cluster based on similarity or distance calculation. And the first algorithm, that is known as k-means. I think before discussing it, let's implement its code, because this algorithm works on 5 steps. So let's understand our problem statement. We have given plants dataset where we have only 2 columns, height and width, and our task is to create 3 groups or 3 clusters. So what we have to do, we have to put all small plants into small cluster. Like if there is a value with lower height and lower width, then we will put that into small plants cluster. And if we have a value for plants height and width, if we have medium width and height, then we'll put into mid, and if we have higher value for height and width, then we'll put into tall plant. That is our task. Okay, so first thing first, import pandas. Since this is I just want to show you how you can implement clustering algorithm like k-means. In next video we will implement end-to-end project like customer segmentation or customer or company customer clustering, where we'll implement k-means. But you must need to understand how you can implement k-means. So first we need to import pandas as a PD. Then from Scikit-Learn .cluster class, you need to import k-means. Okay, this is the class that you will be using. And and we are going to use this data. By the way, this is a dummy data. So here I have created this dummy data with 2 input column, like plant height centimeter. This is a plant with 10 height centimeter. This is another plant with 12 height centimeter. This is another plot, another plot, another plant. So you can increase, and also that plant leaf width in centimeter. Okay, and then I have created this data set. So we have this data where we have total 5 plants with height and leaf width. Now we are going to create another column where we will have 3 cluster. Okay, so we will use this algorithm. So what you basically do, you call this k-means. Let me k-means, and there you pass 2 parameters like number of clusters. So since I'm going to create 3 clusters, this is very important question that we will discuss in this video at the end part. But yeah, for now let me just give it number of cluster will be 3. Random state, you can set anything. So now we have created an object for our k-means algorithm. Now we can apply this algorithm on our data set, this 2 column. So what you can do, you can call this k-means, and since it has couple of parameters like fit, if you just want to train, then you can pass this fit your data set. And let me create a new column by the name of cluster in my data, where I'll store all the cluster. So if I run it, and if I just show the new data, as you can see, we are getting this thing. This is not a good way. So what you have to do, if you really want directly your results or cluster numbers, instead of fit, you need to pass fit predict. Let me rerun like this, and now let me run this. So now we are getting 3 values in this cluster. By the way, let me make it like this. So we are getting 0, 1, 2. So here, as you can see, if the height is 10 centimeter and leaf width is 5, then let me rerun, by the way, because I have created 2 columns. So here you can see if your height and width is higher, then k-means created or generated a cluster 1, as you can see. And if you have medium values, then it's created a cluster by the name of 0. And if you have lower values, then it's created cluster for 2. So this is known as clustering. Quite simple, but we have to give proper names. Like I can create dictionary, label like this, and I will give like so we have this mapping dictionary, where if label is 2, then give it a name small plant. If label is 0, give it medium plant. If label is 1, give it tall plant. Okay, now we have to create another column in our df by the name of plant size, and then we can call our df cluster, and then we can call map method, and then we can pass our cluster map. Okay, so what will happen, it will give you a new column. So if I just show you, now as you can see, we have created a label data that is known as unsupervised learning, where you will get unlabeled data with only input features, and then applying clustering or unsupervised learning algorithms, you have to create a target column. Okay, so next we will plot our 3 clusters. We have to plot our 3 clusters, basically data points, how we created. And you can also plot centroids. Now before understanding this, let's understand how k-means works. I recommend you, after watching this video, I recommend to watch this video as well. So basically, k-means clustering is an algorithm that is used to cluster data into groups or cluster based on similarity points. So it works on 5 steps. It basically choose k value. It decide number of clusters, like as we have decided 3. This is quite important question, because we don't know how many numbers or how many data points, similar data points we have in our data set. So for that we use elbow method technique that we will see in the next video. But after the second step, initialize centroids. So let's say we have our initial data is total 5 records or 5 data points. Okay, now we have created 3 clusters. So from this 5 data points, it will take 3 data points randomly and it will consider centroid, because if you do not have any 3 random data points, then you will not be able to create clusters. And after that, we k-means basically assign nearest data point to nearest centroid. Okay, so using some distance calculation like either cosine similarity or Euclidean distance. So I recommend to watch this video. So if you just understand these 3 steps, let me repeat. Internally, k-means clustering will select number of cluster, which basically defined by us as a developer. Second, it will create, or it will generate, or it will select 3 data points randomly as a centroid. And then for this centroid, it will calculate in third steps nearest data point, and it will, if the data point is similar and nearest that, then it will put in that centroid. Okay, so I recommend to watch this video. This step, second 2 steps are a little bit tricky, but I can't explain right here, but yes, in this video we have explained. Yeah, so if I just plot you, so since we have this data finally, and I am going to plot this cluster. So what I can do, I can run a loop on these 3 clusters. So for I in range 3, and then I will get all these clusters. So this will be my clustered. So I can filter this by going to my cluster column, and if it is equal to I, let me also create these 2 things. So basically, let me cut from here, by the way, here. Okay, so since we have 3 cluster and I want to show you for each cluster a different color, so I have set this list and this is figure. Now since we have this cluster, so we can plot using matplotlib library. So plt dot scatter both height and width from this cluster. So clustered and fetch height, and then clustered fetch width. It should be width, by the way. Sorry, lift width. Okay, so lift width. So if I just run, as you can see, we are getting cluster. So our algorithm is clearly creating clusters or groups for this data. By the way, you can set other parameters like let me quickly paste right here. You can set colors. Here we have pass our colors per cluster, basically this list. And then we have also set label, so that we can see things clearly. As you can see, now we have, this is a cluster, this is another cluster, this is another cluster with proper colors. And if you want to view centroids, you can call your train models, and you can call a parameter by the name of cluster centers. These are the centroids, okay, for all the 3 clusters. And if you want to print or display them, you can do that as well. So let me give it a name by the name of centroids, and now let me plot it using scatter, and here I will call centroids all rows, which is first column like height, and then centroids all data second column, which is leaf width. So if I run it, these are the centroids, but I recommend to use this code. Here we have set color, marker, width. These are some optional, okay, but yes, as you can see, now we have proper plot. So here, this is first cluster where this is the centroid point. This is the second cluster where we have this centroid point, and this is the third cluster where we have this centroid point. So overall, the main objective of this video was to show you what is unsupervised learning problem, and then clustering, types of clustering, and mainly how you can apply k-means, that is the first algorithm for clustering on your data set, and how you can create labels. Now if you get any data set like unlabeled data set and you want to create clusters or groups, then you can exactly follow this code. So this is the second type of clustering, which is density based clustering. Then we will see dbScan, and we will also understand its steps, that how it works. Then we will take this problem statement. Basically we will be using a large shopping mall Wi-Fi data set, and we will be creating cluster for based on signal strength, foot traffic, and distance from the mall. And we'll finally create this cluster like central, strong signal, or high traffic clustering. Okay, we will also create clustering based on their similarity, like moderate signal, moderate traffic, weak signal, low traffic, and some random data. Okay, so let's first understand how density based clustering works. So density based clustering is basically a types of unsupervised learning technique, which is the second type, and it works based on dense region. So let's say we have taken this data set. So density based clustering will consider those data points that are located at once, or you can say dense region. As you can see, this region will be considered a separate cluster, because these data points are lies at the same point, or you can say dense region. And if you take these data points, this will also be considered a cluster, as you can see right here. And this region will also be considered a cluster, because there we have a lot of data points. These data points can be considered outliers, because they are not similar to the other data points. So as you can see, this is the beauty of density based clustering, that basically it considers data points if they are lies in same region, that is known as high density. It will be considered a cluster, and it will separate all the region if it has low density, like these data points. They will be considered outliers. And for density based clustering, you don't need to specify the number of clusters, which was basically the disadvantage of k-means clustering. So this is the algorithm that you will be using for density based clustering, which is known as dbScan. Okay, so dbScan is an unsupervised clustering algorithm that groups together closely packed data points, which is known as high density region, and marks points in low density region as outliers or noise data point. So unlike k-means algorithm, it doesn't require the number of clusters to be specified beforehand. So as you can see, this is the data, and this is a cluster after applying dbScan, and this is another cluster, this is another cluster, this is another cluster. But these black data points can be considered a noise point or outlier. So dbScan works on 5 steps, but I recommend you that if you really want to understand dbScan in depth, then you have to remember few points about dbScan: core point, border point, and this circle. So dbScan basically take a point as a core point, and from this point till the border point, it will draw a line which is known as radius or epsilon distance. And within this core point and this border, if there are a lot of data points lies, that will be considered your entire cluster or entire dense region. So basically in first step, dbScan choose 2 parameters: epsilon, which is basically the radius of neighborhood from core point to the border, okay, and minimum samples. Minimum sample is the number of data points required to form a dense region. So from this core point till your border, you must have at initial stage some minimum samples. It could be 3 or it could be 5 that will create or generate the dense region. Okay. In second step, for each point in the data set, we do few things like count how many points fall within the epsilon distance. Like from core and this border point, we are basically calculating that how many points or data points we have in this region. Okay. If the count of the data points is greater than or equal to minimum sample that you have taken, let's say 5, then it is a core point. If it is in the neighborhood of a core point, then it is a border point. As you can see, this will be your core point and this will be your border point. Okay, otherwise it will consider it as a noise point. In step 3, then you will connect core points within epsilon distance and form a cluster. And in 4th step, you will basically the border points are added to the cluster. So since in this graph we have seen only one border point, but you will have more border point, and you will put them with this core point and you will consider them as a cluster. Okay, and noise remains will be unassigned. So this is the flow. As I didn't discuss everything in detail, but yeah, this is the main point about DBScan. Now let's implement its code. So let's say we have this problem statement. We have a large shopping mall data set about Wi-Fi, and we want to identify natural groupings of Wi-Fi access points based on signal strength, foot traffic near the APIs, and distance from the mall center. Okay, and our outcome, our insight, or you can say our final cluster will be central or strong signal or high traffic, moderate signal, moderate traffic, weak signal or lower traffic. Okay, so let's get started. So since you can use some real data, but since this is, I just want to show you how you can implement DBScan. For that I have generated this data using pandas and NumPy. Okay, if I just show you the data set, you will see in this data set we have 1, 2, 3 columns. Okay, and this is unlabeled data because we don't have beforehand a target column, and this is known as unsupervised learning problem, that you will have input features without corresponding target label or column. So here we have signal strength, foot traffic, and distance from center of the mall in meter. Okay, and based on this data we will generate a new column where we will have these 3 problems or clusters. Okay, now here you can use k-means, but since we are going to learn DBScan, so we will use DBScan. Now before implementing DBScan on this data, we need to scale this data in the form of 0 and 1, so that model, ML model, give equal importance to each data point. So from Scikit-Learn.preprocessing, as we have seen in this playlist, Scikit-Learn tutorials, scaling techniques, like you can use minimax scalar or standard scalar. So I'll use standard scalar. Then let's me create an object for standard scalar like this, and now let's apply this scalar by calling fit transform method or an entire data set, and let me store this in new variable by the name of df scaled or x scaled. Let's say x scaled. Okay, so if I just show you x scaled first 3 rows from 0 to 3 or 4, as you can see now we have scaled data, but in the range of 0 and 1. Initially we have this data, but now we have this data, right? So now let's apply DBScan. So from Scikit-Learn dot cluster, you need to import DBScan. Okay, and now let me create an object of DBScan. Let's say k-means, or let's say model. Let me give it a name, model, and DBScan, and here you have to pass 2 parameters like epsilon. So for now let me just add 0.5. We will discuss this thing a bit later, but let me also add minimum samples, and let's say we are going to start with 5. Okay, now you can call fit predict method and you can pass your scale data, and you can create a new object, let's say clusters. So this will store your generated cluster. So if I just show, if I run, as you can see, if I just show cluster column by calling value counts, as you can see, we are getting 4 cluster. Okay, this is a noise point, we can drop it, but these are our original clusters, so we are getting actually 3 clusters. Okay, but the main question is that how to set this epsilon or radius value and minimum samples. Now is there was an issue with selecting number of clusters for k-min, and for that problem you have used elbow method, and with the help of elbow method or elbow plot you can select best number of cluster like 3 or 4 based on that curve. The same thing you can do with k distance for db scan. Okay, like here you can use nearest neighbor to find the distance to the kth nearest neighbor for each point, and then you can plot the distances sorted in ascending order. So if I just show you, then you will better understand. So before implementing this plot, let me quickly show you that based on this plot how you can select a best epsilon value or minimum sample value. So here you can see from 0 to 100 times on x-axis we have this value, and from 0 to 80 our curve is plane, and from almost 85 you can see our curve becomes automatically rise. So if you want to select best epsilon, you have to eye on your y-axis. So here where your curve becomes rising, you can get that value for your epsilon. So here we can go with 2.5 or let's say 2.6 or 7, you can select for your epsilon. And how to select minimum samples? So again here you have to check on y-axis the point where your curve becomes rising, then you have to get that point. So here we can select 85 or 90 points as a minimum samples of point, but since we are using some dummy data for now, we can go with 0.5 and minimum sample will be 5. But yeah, you can experiment out, let's say 2.5 and 90th will be minimum sample. And let me rerun and let me check how many cluster we are getting. So we are getting only 1 cluster in that case because we are using some dummy data. But what if I use 0.2, let me decrease it, and let me also decrease this sample to 10. So let's say how many cluster we are getting. So here we are getting nothing. So after experiment I get 0.5 and 5 samples I generated best results with. So yeah, now let me show you how you can plot this curve. If you are using some real data, some large data, then you must have to go with this curve, like selecting best epsilon from your y-axis and minimum sample from your x-axis based on the curve rising. Okay, so you can use this code basically. You can use machine learning model nearest neighbors, and you can also import matplotlib. For now we are going to use this minimum samples as a 5. Then we have created an object for neighbor algorithm where we have passed n number as a minimum samples, okay, which is 5. Then we have applied this n on x scale data. These are the neighbors, and after that we have extracted distances and their indices using this trend neighbors class by passing again x scale data, and then we have sorted the distances and then we have plotted accordingly. So once you run, you will get this plot. Okay, so that is the basic flow of db scan. You can implement this code for any type of problem, but if you are using some larger data set. Okay, now as we have seen in previous video that yes, you can also visualize generated cluster. So what I can do, I can just use matplotlib.fixsize figure, and then here let me pass fixed size with, let's say, 8 inches width and 6 inches height. And after that I can run a loop, and then we can run a loop that will basically get cluster label in df cluster column. And since we have 4 clusters, so we can get unique. Okay, and then we can filter cluster data by going to cluster, by going to basically df cluster. Here we have to do filtering. So cluster, if it is equal to our extracted cluster label, then we have this cluster data, and now we can plot it. So we can use plt.scatter, and here we can say that cluster.ilog get all rows of first column, then cluster data.ilog get all rows of second column, and let me also do for third column as well. Or let's say for now let's do it with just 2 columns. Okay, so cluster data first column and second column, accordingly we have set labels. So this should be cluster. Okay, if I just run it, as you can see, we are getting this plot. And if you want to add some title, X label and Y label, then you can use this code. Okay, and we have seen this entire code in previous video as well. This is the similar version. So here you can see we are getting 4 cluster 0 which represent blue data points, cluster -1 which is basically the noise or outlier, cluster 1 green, and cluster 2 red. So you can see our model DBScan has greatly generated cluster for all dance region. Now this is our red cluster, this is our green cluster, this is our blue cluster, and all these points can be considered as a noise data point which is -1. So you can drop that cluster. But now let's create segment, because finally we have this data. You can remove this part, this is optional. But yes, if I just show the new data, as you can see we have this data, but we must have a new column by the name of segments, where we have to give proper name to these labels. Okay, so what I can do, I can say df segments, which is a new column. Then I can say go to cluster and call map method, and here pass dictionary. If you are getting 0, then give it a name of strong. Let me quickly add a mapping. So our final result must be looks like this. So what I can do, I can just go, and here I can create a dictionary by this name, and I can paste this code. So let me remove this, and let me also remove this, and let me also remove this, and let me add this into a string like this, so that we can properly generate our labels name. And let me also fold them into string, and you must have comma right here. So now here, instead of this, I can pass this maps. So if I just run it, and if I just show the new data, as you can see, if I just call sample method with some randomly 5 rows, so as you can see, for this input we are getting weak signal, low traffic, and for this input we are getting central, strong signal, high traffic. So yeah, in that way we implement DBScan. Now, as we have seen in previous video for k-means, that can we create a real-time clustering or segmentation system where we will be using the train model, and it will predict for new input like pathing, signal strength, foot traffic, distance from center, and the model will predict cluster with this label. So the question is no, because DBScan has no parameter, and it is a non-parametric model, so you cannot do a real-time cluster with segmentation, but yes, you can do by using some other technique. That the third type of clustering, which is known as hierarchical clustering. So this is quite simple. So if I just give you an overview by taking this example, so in case of hierarchical clustering, what happens? Initially, it will take each data point as a single cluster. So let's say we have only this data set, and here all these characters are data points, like H is a single cluster or data point, G is a data point, F, and until A. So all these data points, we have all these values are data points. So once you apply hierarchical clustering on this data point, so in first step, or you can say initially, hierarchical clustering consider each data point as a single cluster. In second step, it will calculate distance. It could be Euclidean distance, Manhattan distance, that we will see. So during that distance, it will find out nearest data points based on their distance. So here you can see H, G, and F are nearest data points. So it will create another cluster by the name of FG. And here E and D are nearest data points, so it will create another data cluster by the name of DE. And here you can also see for C and B, it will create another cluster by the name of BC, because these data points were nearest in case of distance. Next, what will happen? It will again calculate distance for this new cluster and this old one. So here you can see these two clusters are similar, or you can say nearest in case of distance. So it will create another cluster by the name of FHG. Here DE and BC are nearest, so it will create another cluster by the name of BCDE. Again it will calculate, so again it you can see BCDE and A are nearest, so it will create another cluster. And again in this level, this two cluster ABCDE and FGH are nearest, so it will create finally this cluster. So it will start from bottom, and initially it will consider each data point a single cluster, and it will calculate distance, creating and merging all cluster until it combine all data points as a single cluster. This is known as hierarchical clustering. And hierarchical clustering has two types, but before that let me quickly give you this definition. So hierarchical clustering is an unsupervised machine learning algorithm that is used to group similar data points into clusters based on hierarchy, because it builds a tree-like structure that is known as dendrogram, that we will see through a graph, to represent nested clusters at different levels of similarity or dissimilarity. Okay, so the first type is agglomerative, which is also known as bottom-up approach, and this is the diagram, and it works exactly in the same way that I have explained. So at first step, it will start with each point as its own cluster, so it will consider each data point as a single cluster, and iteratively it will merge the closest clusters until all data points belong to a single cluster, as you can see. So this is known as agglomerative clustering. The second type is divisive clustering, which is basically the opposite of agglomerative clustering, or it's also known as top-down approach. So it basically starts with all points in one cluster. So as you can see here, it will consider all data points as a single cluster, then based on dissimilarity, not similarity, based on dissimilarity or not closeness. Previously in case of agglomerative, it will calculating similarity or nearest distance, but this time it will calculate dissimilarity or far away from each other. Okay, so recursively it will splits the cluster into smaller cluster based on dissimilarity until it reaches to different cluster, or for each data point a separate cluster. This is known as divisive clustering. Okay, so basically you will work mostly in real world if you have a problem statement related to agglomerative clustering or hierarchical clustering. So in real world, you'll be mostly working with agglomerative clustering. And the second point that you must note, there is no class in Scikit-Learn for divisive clustering. You have to implement recursive k-means. You can implement, but you have to use custom code. But for agglomerative clustering, we have a class in Scikit-Learn. So these are the 5 steps on which hierarchical clustering works. It calculates distance between every pair of points. The distance could be Euclidean distance or Manhattan distance. Then assign each point to its own cluster, and then merge the closest cluster based on linkage criteria like single, complete or average, and then repeat until all data points become or merged into a single cluster or finally big one cluster. Okay, so how to know best cluster? As in k-means, we have to plot the data 10 times and then we'll be able to find the best curve, and that curve gives you a number of best clusters like 3 or 4 in k-means. But how to find best numbers of cluster in case of agglomerative? For agglomerative, you use dendrogram, that you will see a bit later, but let's see implementation. So I have imported NumPy, matplotlib, and since I'm not going to use real world dataset, I'm going to create my own dataset. So for that, from Scikit-Learn dataset, I have imported macblobs. This is the class. With the help, you can create your own dataset. Okay. And after that, from Scikit-Learn.clusters, as previously we have imported already, like k-means or dbscan, you can also import agglomerative clustering from cluster. Okay. And if you want to calculate linkage or dendrogram for agglomerative clustering, then you have to go to cluster. You cannot do that in Scikit-Learn, but there is another library, SciPy. You can go to scipy.cluster, and from cluster.hierarchy, you can import dendrogram and linkage. Okay, here I have created this data set with 100 data points and 3 centers. Okay, so after that I have plotted using scatter plot. So as you can see, this is the original data. Now you might be thinking this data is already clustered. Yes, definitely this data is already clustered. You don't need to work on it, but we need to make sure that is this data already clustered or not. And also in real world scenario, you will not get such type of data set that is already clustered. So what basically we do, we create an object of our unsupervised learning algorithm, which is agglomerative clustering. You will pass here number of clusters, same like in dbscan or k-means. So initially I have said 3. Linkage will be what? This is basically the selection of different levels. And here we have different types, as I have mentioned here, like single, complete, average and what. So total 4 types. What is basically the sum. And then we have called model.fitPredict. We have passed our entire data, and these are the labels. Basically you will have 3 clusters, 0, 1, 2. Now if you want to plot this cluster, then we have called cluster. We have passed the 2 column and our labels with this map, and here you can see now we are sure that yes, this data is properly clustered. But if you are dealing with original data set and it is not already clustered, and once you apply your agglomerative clustering, then you will see the plot somehow like this. Okay, now if you want to find out the best numbers of cluster, then what basically you do, you call linkage. Okay, this is the class that we have imported from scipy.cluster.hierarchy. You have to pass your entire data, and here you have to pass the method. This method is basically the level. This is the first level, this is the second level, and this is the third level. So here you can pass complete, single, all those. Okay, then we have created figure, and then we have passed this finally linked to our dendrogram, because for selecting best number of clusters for agglomerative clustering, you have to use dendrogram. So this dendrogram will give you this plot. Okay, now here the main question is how to select best number of cluster. So you have to find out the level. As you can see, this level is the best level, because on this level I am sure and I am getting the best numbers of clusters, because this level or you can say this dendrogram or link represent more clusters, or more combining or merging more data points. This one do the same, this one do the same. So I can say this level is the best numbers of clusters. So here we have 3, like 1, 2, 3. So you can go with 3 numbers of cluster. But if you see one more right here like this one, then this will be level 2. So then select that level. So you have to select the best level. Okay. So if you are seeing another dendrogram or linkage of level right like this, then select this level or dendrogram. So in that case it will be 2 number of clusters. So currently at the moment we have selected 3, but if you are getting 2, then you have to pass 2. Okay, so yeah, that was the entire discussion and implementation behind hierarchical clustering. As I have already mentioned, if you want to use divisive or top-down approach, then you are not able to use Scikit-Learn. Then you have to use Scikit-Learn k-means class with some custom code.